All right, everyone, buckle up, because today we are diving deep into Seed Music.
Seed music?
This AI music generator that has everyone buzzing. And let me tell you,
Yeah.
this is not just another AI story.
No.
We are going way beyond the hype.
Absolutely.
They're talking about what's under the hood, how it really works,
Yeah.
the nitty-gritty,
The good stuff.
and why you should care. Right.
You got it.
So we dug into their technical report.
It's fascinating stuff.
It is, and you can find it linked in the show notes if you want to follow along at home.
Please do.
But fair warning, it's pretty dense.
It's a little thick.
That's why we are here to break it down for you.
Exactly.
So right off the bat,
Yeah.
Seed Music, they're tackling some really big challenges.
Huge. Yeah. It's not just about putting notes together. It's about capturing the essence of music, the human expression,
Yeah.
the nuances. Like you think about a guitar solo or a vocal melody. These are things that are hard to put into words.
Absolutely.
It's the way the sounds evolve over time.
Right.
The little variations, the way they build tension. That's what makes it feel human.
It's like the difference between reading lyrics and actually performing them.
Yes, exactly.
Like with emotion.
100%.
And then, I mean, on top of that, there's the technical side of things.
Oh, absolutely. The AI has to understand rhythm, tempo, how instruments work together.
Right. It's a whole sonic landscape.
Yes, exactly. Not just random notes.
Not just throwing things at a wall and seeing what sticks, right?
No, not at all. And Seed Music claims to do just that. And the approach is really cool because they are using not just one, but 3 different AI techniques.
Oh, wow.
It's like they've got a whole toolbox.
A specialized toolbox.
Yes, exactly, for music creation.
Okay, now you've got me interested.
Yeah.
A whole toolbox. Okay, now you've really piqued my curiosity. What's the first tool we're talking about here?
So first up, we have these things called audio tokens. Imagine, like, if you could take a sound
Yeah.
and break it down to its tiniest parts.
Yeah.
Almost like musical DNA.
Physical DNA.
Yeah, and these tiny bits of information, that's how Seed Music actually makes sense of sound.
So it's like the atoms of music, right?
Yeah.
Like breaking it down to its fundamental building blocks.
That's a really good way to put it, actually. Each one of these tokens captures everything about the sound, the pitch, the tone, all those little nuances that make each instrument sound unique.
Wow. So we're talking like massive amounts of data here, right? To process even a single song.
Oh, yeah. Thousands, potentially even millions of these tokens just for one song.
See, that's what blows my mind about AI. Like our brains could never handle that.
Not a chance.
But AI can just crunch through it, no problem.
Exactly. And that's where it gets really interesting because the AI can look for those patterns in the data, the things that we as humans would take forever to find.
Okay, so hold on. I'm trying to wrap my head around this. So Seed Music analyzes the music, breaks it down into these audio tokens.
Yeah.
It's like taking a complex recipe and dissecting each ingredient,
Yeah.
right? But then how does it actually use that to create something new?
Well, that's where the magic happens, right? The AI starts to learn how all these different tokens go together. It learns the relationships between them, how they interact to create melody, harmony, rhythm, all the elements of music.
So it doesn't just see the ingredients, it learns the actual recipe.
Precisely.
That's incredible.
Yeah.
But I think you mentioned there's a bit of a downside to this audio token approach.
Yeah, so as amazing as audio tokens are for AI, they're not exactly easy for us humans to understand.
Right.
Like, you can't just look at a string of audio tokens and instantly hear the music in your head.
It's like trying to decipher a recipe written in a language you don't know.
Yes, exactly. You might recognize a word here or there, but
You wouldn't know what it's supposed to taste like.
Yeah.
Okay, so that's where this second tool comes in.
you got it. Seed Music also uses what they call lead sheet tokens, and this is where it gets especially cool for anyone who's ever dabbled in music themselves.
Oh, really? Tell me more.
So instead of just raw sound, lead sheet tokens, they represent things like melody, chords, rhythm, all those traditional music theory concepts.
Hold on. So Seed Music can actually understand music theory.
In a way, yes.
That's wild.
It's like having a blueprint, right? Instead of just a jumbled pile of materials, you've got a plan to follow.
So it's like the difference between trying to build something from a random assortment of Legos versus having the actual instructions.
Exactly. You get a much more structured, controlled result.
Okay, that makes a lot of sense. So we got audio tokens for breaking it all down, lead sheet tokens for speaking the language of music. What's the third tool Seed Music is using?
All right, this one gets a bit more technical, but stick with me. It's called vocoder latents.
Vocoder latents. Okay, you're losing me a little, but I'm intrigued.
Basically, imagine trying to capture the feeling of a sound. Not just copying it note for note, but understanding the essence of what makes it sound that way.
Okay, like trying to describe a color to someone rather than just giving them the exact same shade?
That's a great analogy. It's about capturing the texture, the emotion behind the sound.
I see, I see. So if audio tokens are the raw ingredients and lead sheet tokens are the blueprint, then vocoder latents are like the artistic flair.
Yes, that's a great way to put it. It's what allows seed music to go beyond just replicating existing styles and create something truly unique and expressive.
Wow. Okay. So we got these three amazing tools all working together. It sounds like seed music really is like having a musical Swiss Army knife.
It really is. And the best part is, this is just the tip of the iceberg in terms of what seed music can do.
Wait, there's more. Okay, now I have to know, what can seed music actually do with all of this?
Well, let's get into the really exciting stuff. Seed music has 4 main applications: lyrics to song, lyrics to lead sheet to song, music edit, and zero-shot singing voice conversion.
Whoa, those are some serious names.
Right. They definitely sound like they could be straight out of a sci-fi movie.
They do. All right, break them down for us. What makes each of these so unique?
Okay, so let's start with lyrics to song. As the name suggests, you give it some lyrics,
Right.
you tell it what style of music you want,
Okay.
and bam, it creates a whole song, complete with vocals.
Seriously, just like that.
Just like that. But what's really cool is that seed music can create music in pretty much any style you can imagine. We're talking everything from a power ballad to a Mozart-style aria, you name it.
So I could take, like, lyrics from my favorite pop song, feed it to seed music, and hear it as a death metal track.
You absolutely could, and I'd love to hear that, actually. It's that versatility that really makes seed music stand out.
Wow, that's seriously impressive. Okay, what about lyrics to lead sheet 2 song? That one sounds interesting, especially for actual musicians.
You're right, it is. This one is all about bridging that gap between AI and human creativity. So just like lyrics to song, you give it lyrics and a style, but this time it also spits out a lead sheet that you can actually edit yourself.
Wait, hold up. So it's like the AI gives you a solid first draft of the song,
Yeah.
and then you, the musician, can come in and tweak it to make it your own.
You got it. You can keep the parts you like, change the melody, add a bridge, whatever you want.
That's a game changer. It's like having an AI writing partner who never gets tired or throws a tantrum when you want to make changes.
Exactly. And the last 2 applications, Music Edit and zero-shot singing voice conversion, are even more futuristic, if you can believe it.
Okay, now you're just teasing me. Tell me everything. Okay, spill the beans. Music Edit and zero-shot singing voice conversion.
All right.
Lay it on me.
So, Music Edit. Think of it like having a magic wand for your music.
Okay.
You can take an existing track and make changes without starting from scratch.
That sounds dangerous.
It is, but in a good way. Like, let's say you want to change the lyrics
Right.
or adjust the melody, even rewrite whole sections of the song.
Yeah.
You can do all of that with Music Edit.
No way. So I don't have to, like,
You won't.
re-record the entire track.
Exactly. It's a huge time saver.
That's insane. Okay, what about that last one?
Zero-shot singing voice conversion.
Zero-shot singing voice conversion, yeah.
This one is still in the works, but it's mind-blowing.
Okay.
Imagine being able to sing,
Okay.
but with anyone's voice.
Wait, whose voice?
Anyone. Like, you could have your voice
Not
singing,
a voice. Okay.
even if you're a terrible singer.
So you're telling me I could finally live out my rock star fantasy,
Exactly.
even though I sound like a dying walrus when I sing in the shower.
Well, don't underestimate the power of technology, right? But that's the thing about seed music. It's not just a cool toy. It has the potential to revolutionize the way we think about music.
Absolutely. This has been like a mind-blowing deep dive. Seed music is really pushing the boundaries of what we thought possible with AI and music.
I totally agree. And this is just the beginning. Imagine where we'll be in a few years.
I know, right? It's both exciting and a little bit terrifying.
Yeah.
But hey, that's the future for you. Make sure you check out the show notes for links to Seed Music's demos and let us know what you think. Is this the future of music? We want to hear from you. Until next time, keep those musical minds of yours churning.
AI is exploding right now, isn't it?
It really is.
It seems like every single day there's some new tool or a new app
Yeah.
that's powered by these large language models, these LLMs.
All right.
And, you know, you've probably even played around with a few of them yourself, the
Yeah.
ones that can, like, write poems or crack complex code.
Yeah.
But have you ever stopped and thought about
Yeah.
how do these AI heavyweights,
Yeah.
how do they handle really long pieces of information.
Yeah, it's a good
Like,
question.
I'm talking about analyzing a massive research paper,
Right.
or even like a whole textbook worth of text.
Yeah, it's a fascinating challenge.
Yeah.
LLMs, they have this thing called a context window.
Okay.
And you can kind of think of it like their working memory.
Mm.
It's basically their mental capacity for holding on to information
Yeah.
while they're processing text.
So it's like the LLM has this mental backpack.
Yeah, exactly.
But there are limits to how much it can actually carry.
Right.
So what happens when you need it to analyze something massive, like a digital library?
That's where things get really tricky.
Yeah.
Because the bigger you make that backpack, that context window, the more processing power and memory the LLM needs.
Okay.
And traditional LLMs, even the really impressive ones that we hear about,
Mm-hmm.
they start to get really sluggish.
Yeah.
And they even stumble when they're dealing with those super long chunks of text.
And why is that? Why do they struggle so much?
Well, it all comes down to how these LLMs are actually processing information in the first place.
Okay.
They use something called an attention mechanism. And so think about how you read a sentence.
Mm-hmm.
You don't give equal weight to every single word in that sentence.
Right.
Your brain naturally focuses on certain key words, the ones that are carrying the most meaning.
Yeah.
And LLMs try to do the same thing. But their way of figuring out which words are important, it can be incredibly resource intensive, especially as you start dealing with longer and longer texts.
So it's not as simple as just feeding the LLM more information?
No, not at all.
There's a bottleneck in how it actually sifts through and understands all that data.
Precisely.
Hmm?
And that is what makes the research paper that we are going to be diving into today so intriguing.
Okay.
It's called Retrieval Attention, Accelerating Long Context LLM Inference via Vector Retrieval.
Wow.
And it presents this really clever way to kind of overcome that limitation.
Okay, I'm definitely intrigued. So how does it work?
Yeah.
Do they somehow make the LLM's backpack bigger, or are they doing something totally different?
Well, they kind of found a way to make the LLM work smarter, not harder, so to speak.
Yeah.
You see, even though attention seems like it's analyzing everything,
Right.
it's really only a subset of words that really matter the most for understanding the context.
So it's like realizing that you don't need to pack your entire closet for a weekend trip.
Exactly.
You really only need a few essential outfits.
Precisely. And the researchers, they realized that they could leverage this inherent sparsity of attention
Okay.
to make LLMs much more efficient at processing these long contexts.
Now, I know we've seen other attempts to tackle this before.
Right.
What about some of those existing solutions? Like, what about streaming LLM and Snap KV? How does this retrieval attention compare?
So you're right. There have been attempts to make LLMs better at handling these long contexts.
Right.
And it's a streaming LLM that tries to kind of simplify things by just focusing on the most recent information.
Okay.
Kind of like how we tend to remember the last few things that we've read more clearly.
Yeah.
And then there's Snap KV, which tries to predict what information will be important in the future.
Oh, okay.
And so it's like trying to pack for that trip again.
Right.
But you can only take things based on what you think you'll need at the very end.
Yeah.
And as you can imagine, these approaches, they have their limitations.
Right. Yeah.
Language is fluid and it's dynamic.
Yeah.
And those methods just lack that flexibility to truly adapt to the ever-changing context of a really long text. Retrieval attention takes a different approach altogether.
Okay, so how does retrieval attention actually work?
Yeah.
What makes it so different? So it sounds like they're tapping into this idea of sparsity
Right.
to make things more efficient.
Exactly.
But you mentioned those other approaches, stream and LLM, Snap KV,
Yeah.
trying to solve a similar problem.
Right.
Where does retrieval attention fit into all of this?
So retrieval attention, it's like imagine you have this super organized assistant.
Okay.
And instead of handing the LLM, this huge stack of papers and saying, go find what you need,
Right.
this assistant, they pre-read everything.
Okay.
And they create this really, really detailed index,
Okay.
like chapter markers in a book, right? So when the LLM needs a specific piece of information, the assistant can very quickly just fetch it from the index.
That sounds incredibly efficient.
It is.
So retrieval attention is basically offloading all that heavy lifting
Yeah.
to this, assistant.
Precisely. And here's the really clever part.
Okay.
They actually use the CPU for this, which is typically much better suited for these kind of indexing and searching tasks.
Okay.
Meanwhile, the LLM, it can focus on what it does best, which is actually understanding and generating human-like text.
It's like having this specialized team working behind the scenes.
Exactly.
Each part optimized for their own specific task.
Yeah, yeah.
But I'm guessing it's not quite as simple as just creating an index.
You're right to be skeptical. One of the biggest challenges they had to overcome is this thing they call the out-of-distribution challenge.
Out of distribution.
Yeah, so the way that the LLM searches for information, it's fundamentally different from how, like, traditional databases work.
Okay.
It's almost as if the LLM is speaking a different language
Okay.
when it's trying to find what it needs.
So you have this efficient index,
Right.
but the LLM doesn't quite know how to use it effectively.
Exactly.
So how did the researchers bridge that communication gap?
This is where things get really, really interesting.
Okay.
They realized that they could use the LLM's own knowledge
Okay.
to actually teach it how to search more efficiently.
Okay.
And they call this the pre-fill stage.
Pre-fill.
Yeah.
So the LLM gets like a sneak peek at the information beforehand.
Exactly.
Almost to understand how to search it better.
Exactly. It's like giving the LLM a quick tour of the library
Right.
before letting it loose to do its research.
Okay.
And so this helps the LLM really understand, like, the nuances of the language that are being used in that specific text, and then build a more LLM-friendly index.
It's almost as if the LLM is learning to speak the language of the index.
Yeah, exactly.
So how effective is this approach in practice?
It's actually quite remarkable.
Okay.
They were able to, by using this attention-aware approach, drastically reduce the amount of data the LLM actually needs to scan from about 30% down to just 1 to 3%.
Wow.
It's a huge difference.
That's incredible. Wow, going from 30% down to 1 to 3%, that's a huge DE improvement.
It is.
That's like going from searching for a needle in a haystack to like having a metal detector.
Exactly.
But what does that speed boost actually mean in real world terms?
Yeah, so it's a game changer, really.
Check. Yeah.
Their research shows that retrieval attention, it can make LLMs up to 4.9 times faster.
Wow.
And here's the best part.
Oh, okay.
They were able to achieve these speeds on just a standard RTX 4090 GPU,
Okay.
which a lot of researchers and developers, they already have.
So we're not talking about like some theoretical supercomputer here.
Right.
That's inaccessible to most people. This is something that could be implemented like now.
Yeah, absolutely.
So what are the implications of that kind of like speed and accessibility?
Well, it opens up a ton of possibilities. Imagine, like, researchers being able to analyze these massive data sets of medical research,
Right.
but in real time.
Right.
Or historians being able to get, like, instant insights from these centuries-old archives.
Wow.
And it's not just limited to research either, right?
Right.
Think about businesses
Right, yeah.
being able to analyze customer data, personalize experiences, even automate complex tasks, all with the power of AI, but now it's faster,
Right.
more efficient.
It's like you're giving superpowers to all these different fields.
Yeah.
You know, we talk about AI being this powerful tool,
Right.
but this feels different. This feels like it could democratize access to that power in a way that we haven't really seen before.
You hit the nail on the head.
Okay.
What excites me most about this research is, like, the potential for wider adoption. With retrieval attention, you don't need a massive budget. You don't need access to a supercomputer
Right.
to actually harness the power of these LLMs.
Yeah.
This could empower smaller businesses, independent researchers,
Yeah.
even just individuals
Right.
to leverage AI in ways that were previously unimaginable.
That's a really inspiring thought.
It is.
So as we kind of wrap up our deep dive here on retrieval attention, what's the key takeaway you want our listeners to remember?
I think this research really signifies a shift in how we approach AI development. It's not just about making bigger and more complex models. It's about making them smarter, more efficient, and more accessible.
Okay.
And retrieval attention is a fantastic example of how innovative approaches can unlock the full potential of AI, make it faster, more powerful, and available to a much wider audience.
It's definitely given me a lot to think about.
Me too.
I'm really excited to see how this technology develops and what new possibilities it unlocks in the world of AI.
As am I. It's a really exciting time to be following this field.
Yeah.
And research like this, it just gives us a glimpse of what that future holds.
Absolutely. Well, that is another deep dive in the books. If you are as fascinated by this as we are, we encourage you to check out the full research paper, Retrieval Attention, Accelerating Long Context LLM Inference via Vector Retrieval.
It's a good one.
Trust us, it's worth a read.
It is.
Until next time, keep those brains engaged.
Absolutely.
Keep exploring.
Keep learning.
Okay, get this. Imagine teaching AI to read comics. Not just recognizing the pictures, but actually understanding the story, the humor, the drama, just like you would.
That's a fascinating challenge, isn't it? Comics rely so much on visual cues and unspoken communication. Things we as humans intuitively grasp, but are incredibly complex to code.
Exactly. And that's what makes this whole area of research so intriguing. We're diving into a paper today that explores this very intersection of AI and comics. Trust me, you're going to want to hear this.
I'm ready. What are some of the key things that make comics such a unique challenge for AI?
Well, the paper spends a good chunk of time highlighting how different comics are from other visual mediums. It's not like analyzing a photo. You've got different panel layouts, reading orders, art styles that can change drastically. Even things like onomatopoeia, those sound effect words, play a crucial role in the storytelling.
It's true, we often take those elements for granted as readers, but for AI, each one presents a hurdle. For example, even determining the reading order of panels, which seems simple to us, can be surprisingly tricky for a computer to figure out.
And what's wild is the paper even mentions how humans sometimes struggle with panel order, especially when you get beyond those classic four-panel strips.
That's a really important point. If we, with our complex brains, sometimes falter, imagine how difficult it is to design an algorithm that can do it perfectly every single time. It really highlights the magnitude of the task for AI researchers.
Right. It's like we're asking AI to decode a secret language that even we don't fully understand. But here's the thing. Researchers are developing some ingenious methods to tackle this, and a key one outlined in the paper is this framework called the Layers of Comics Understanding, or LOCU for short.
Okay, layers of comics understanding. It sounds almost like a superhero's power levels. What's the idea behind this LOCU framework?
So picture it like levels in a video game. Each layer represents a higher level of understanding that AI needs to achieve to truly get comics. There are 5 layers in total, and the paper dives into each one.
Right, so walk me through these layers. What kind of skills is AI tackling at each level?
So layer 1 is the foundation, the basic stuff, identifying images, improving their resolution, even converting them into different formats. Important groundwork, but not exactly mind-blowing on its own.
Right, it's like teaching AI the alphabet before it can read a novel. Essential, but just the first step.
Exactly. Now, layer 2 is where it starts to get interesting. This is where AI is learning to identify individual panels, detect characters, and even figure out who is speaking in each speech bubble.
Now we're getting to the heart of understanding a comic's narrative flow. Being able to link dialogue to the correct speaker is crucial.
Absolutely. And it builds on that foundational layer 1 processing. Now, layer 3 focuses on understanding the action and interactions between characters, like who's looking at whom, who's doing what. It's getting a sense of the scene's dynamics.
It's like AI is learning to read body language, but in this case, it's deciphering the visual language of comics.
And that takes us to layer 4, which for me is where things get really mind-blowing. We're talking about AI that can answer questions about the comic.
Whoa, hold on. Answering questions.
Yeah.
You're saying AI could understand the plot, the emotions, the themes.
You got it. Imagine giving AI a comic and asking, what's the mood of this scene, or what might happen next based on what we've seen so far? That's the level of understanding layer 4 is aiming for.
Okay, now that is impressive. It's one thing to recognize elements, but to actually start interpreting them, making inferences, that's a whole new level of cognitive ability.
It really is. And while it's still early days, the paper highlights some seriously impressive progress in this area. But we'll dive into those specifics in just a bit. First, let's talk about layer 5, the peak of this comic understanding mountain. This is where AI ventures into the realm of creation.
Creation, you mean AI actually making its own comics?
You got it. Layer 5 is all about using AI to generate entire comic strips or even full-blown graphic novels, complete with visuals, dialogue, the works. Imagine feeding AI a story idea and having it spit out a fully realized comic.
Wow, that's incredible, though. I can only imagine the complexities involved. You need AI that understands narrative structure, character development, visual composition. It's a monumental task.
It truly is. And while we're not quite at the point of AI churning out New York Times best-selling graphic novels, the research in this area is super exciting.
This LOCU framework really lays out a fascinating roadmap for AI development. It's like you said earlier, it's like watching AI level up its skills in the world of comics.
Exactly. And what's really cool is that the paper doesn't just present this framework in theory, it dives into specific examples of how researchers are tackling each layer, the wins they're seeing, and the hurdles they're still facing.
Okay, I'm hooked. Let's talk about some of those wins. What are some areas where AI is surprisingly good at understanding comics? Yeah, I'm hooked. Let's talk about some of those wins. What are some areas where AI is surprisingly good at understanding comics?
Well, one area where AI is really starting to shine is character re-identification.
You mean being able to tell it's the same character,
Yeah. Exactly.
even if their look changes from panel to panel?
Exactly. Think about how Spider-Man, for example, can look drastically different depending on the artist.
Right.
Or even just the angle of the panel. But for us, it's still obviously Spider-Man.
Right. We recognize him based on his overall build, his web pattern,
Yeah.
those key Spidey features.
And that's essentially what researchers are training AI to do as well. The paper talks about some seriously cool techniques they're using, things like dual ring loss and adaptive reweighting, which sounds super complex.
I do sound a bit intimidating.
Right.
All that.
But the gist is these techniques help AI focus on those key identifying features of a character, just like how we subconsciously do it as humans. It's like teaching an AI to recognize its friends even if they show up rocking a new haircut.
That's a great analogy. So they are making headway, but this is cutting-edge stuff. I imagine there's still plenty of challenges. Where does AI still fall short in understanding the nuances of comics?
Well, one area the paper highlights is translation.
Translation. That seems straightforward, doesn't it? I mean, can't you just run the text through Google Translate and call it a day?
If only were that simple. See, with comics, translation isn't just about swapping out words. You have to consider things like how the translated text fits within the speech bubbles, how to convey humor that might be visual or culturally specific, and don't even get me started on onomatopoeia.
The classic sound effects. It's true, those can be incredibly language-specific and deeply tied to cultural understanding.
Exactly. And the paper points out how this is a huge stumbling block for AI. It's not just about linguistic translation. It's about translating the entire experience of reading a comic, which is so deeply intertwined with visual and cultural cues.
It's fascinating, isn't it? We often overlook how much we take for granted when we read a comic.
Yeah.
It seems effortless, but there's a complex interplay of language, visuals, and cultural context happening beneath the surface.
Absolutely. And that brings us to another area where AI is still finding its footing, generating entirely new comics from scratch. Feeding an AI a story idea and having it spit out a full-fledged comic.
Right, like that layer 5 we were talking about. That feels like the holy grail of AI in comics.
It really does. But as you can imagine, it's incredibly complex. It requires the AI to not only understand all these layers of comics we've been discussing, but to actually use that understanding to create something new and engaging, complete with its own unique visual style and narrative voice.
It's asking AI to become an artist, a storyteller, a master of visual communication, all rolled into one.
Exactly. Now, while it's still early days and we're not quite at the point of AI-generated graphic novels hitting the shelves, the research in this area is pretty mind-blowing. Researchers are developing AI models that can generate individual panels, character designs, even entire page layouts. It's really quite remarkable.
So it sounds like we are still in the early chapters of this story. But even in these early stages, the implications extend far beyond just creating the next Spider-Man comic.
Exactly. And this is where things get really interesting for everyone, even if you're not a die-hard comic book fan.
Okay, now you've got my attention. Tell me, how does all this research on AI and comics relate to someone who might not even pick up a graphic novel?
Well, think about it. All these advancements in AI, all these techniques for understanding visual narratives and complex information, they have huge implications for tons of different fields.
I see what you mean. It's not just about comics, it's about the technology itself and how it can be applied.
Precisely. For instance, take something like content moderation.
Content moderation, how does that tie into AI reading comics?
Think about all the visual content online, from social media to online forums. This technology could be incredibly useful for identifying things like hate symbols, violent imagery, or other harmful content in a way that goes beyond just recognizing text. It could analyze images, understand the context, and flag potentially problematic content with much higher accuracy.
That makes sense.
Yeah.
It's like teaching AI to be a more sophisticated and nuanced moderator, understanding the subtleties of visual communication.
Exactly. And another area where this technology could be huge is accessibility. Imagine being able to create AI that can read a comic aloud to someone who is visually impaired, conveying not just the words, but the emotions, the sound effects, the entire experience in an immersive way.
That's incredible. It could open up a whole new world of storytelling and entertainment to people who might not have had access to it before.
Exactly. And what's fascinating is how this research is pushing the boundaries of several different fields within AI. It's not just about computer vision or natural language processing, it's about combining those fields in new and innovative ways.
You're talking about multimodal learning, right?
Yeah.
That idea of AI learning from multiple types of data at once.
Exactly. And comics, with their unique blend of visual and textual elements, are proving to be the perfect testing ground for this type of advanced AI development.
It's like this niche field is becoming a catalyst for some really groundbreaking advancements in artificial intelligence, forcing researchers to think differently about how we teach machines to understand the world around us in all its complexity.
And here's another cool ripple effect all this research is driving the creation of some truly valuable data sets. The paper mentions one called Comics, which is a massive collection of comics that's been carefully annotated with all sorts of information from panel types to character emotions to the overall storyline.
Oh, wow.
Right?
I can see why that would be valuable.
Mm.
Data is the fuel that powers AI, and having access to a data set like that one that's specifically designed for training AI to understand comics is pure gold for researchers.
It totally is. And the best part is this comics data set can be used for research in tons of different areas, not just comics. It's a treasure trove of information for anyone studying visual storytelling, artificial intelligence, or even just human psychology.
It's incredible to think that this quest to teach AI how to read comics could end up having such far-reaching implications. It really speaks to the power of curiosity-driven research.
It does. And you know what else I found really fascinating? The paper mentions this idea of using AI to generate sound effects for comics. You know, it's funny. Earlier we were talking about those low CU layers, right? And how layer 5 was all about AI actually creating comics.
Yeah, the idea of AI being like a comic book author, basically,
Yeah.
generating whole stories.
Exactly. Well, this paper, it throws in this almost like offhand comment about using AI for something else creative, generating sound effects for comics.
Wait, what? Like you mean AI creating the boom and the cop all and all that you see in the panels?
Yes. Imagine you're reading a comic, but as you're going through it, you also hear those sound effects, maybe even synced to how fast you're reading or something. The paper just mentions it briefly, but it totally got me thinking.
Now that you mention it, yeah, that could be really interesting. I mean, how do you teach an AI to do that? Would it just be based on what's visually in the panel? Or would it have to, like, understand the mood, the context, the way a human sound designer kind of would?
Right. And then there's the style too, right? Like, should those AI-generated sounds be realistic? Or should they be more like, those classic comic book sounds we're used to? How much creative license does the AI get,
It'd be like adding a whole other layer of sensory experience to comics. I bet you could do some really cool things with genres like action or horror, where sound is so important for the mood.
And you know what else? Think about the accessibility angle. We were talking about AI reading comics aloud for people who are visually impaired. But now imagine if it could do the sound effects too on the fly, maybe even tailored to the reader's preferences.
It's amazing when you think about it. This whole field, AI and comics, it just seems to be full of potential. Even something as, I don't know, seemingly basic as sound effects, it branches out and could change things in ways we haven't even thought of yet.
I totally agree. This whole deep dive has really shown how even research that seems really niche like this, it can end up having these big ripple effects,
Yeah.
pushing the boundaries of what we thought was possible. We started with AI learning to read comics, and now we're talking about AI enhancing them, maybe even creating completely new ways to experience them.
Who knows what's next? Maybe we'll all be reading our comics with personalized AI soundtracks someday.
Or even AI co-creators helping us come up with stories in ways we never could have imagined before. It's definitely an exciting time to be paying attention to this field, that's for sure. And for anyone listening who's, as fascinated by all this as we are, we'll make sure to include a link to that paper in the show notes. It's a really interesting read, even if you just skim the good parts. Until next time, keep exploring, keep asking those interesting questions, and most importantly, keep learning. Hey everyone, ready for another deep dive. You guys sent in some seriously cutting-edge stuff this time, straight from Arkansas.
Fresh off the press.
We're talking about something called Kolmogorov-Arnold transformers. KTs for short.
Catchy, right?
Definitely easier to say. But this isn't just about a cool name. We're diving into how these KTs could totally change the game for AI. Big time.
No exaggeration there. Transformers are already the backbone of, well, almost everything AI these days.
Seriously, those chatbots that sound eerily human.
Image editors that make you look like a pro, Transformers are behind the scenes.
And this paper, it's like taking those Transformers and giving them a supercharge.
Most research out there focuses on tweaking the systems around Transformers.
This one's different.
This paper goes right for the core. The fundamental building blocks, they're challenging assumptions that have been around for ages.
Okay, so we're talking foundational changes. For those of us who aren't AI engineers, bring it down.
Imagine this. A transformer is like a master chef, incredible at combining ingredients in new ways. That's their attention mechanism.
Delicious. What's the problem then?
Now imagine this chef, stuck with a basic stovetop. Limited heat settings, no fancy gadgets. That's the MLP, the multi-layer perceptron.
Well, what now?
It's the engine, the workhorse of the AI. Handles all the information processing. But like that basic stove, it has inherent limitations. This paper digs deep into those, especially when it comes to AI learning intricate patterns, and fast.
I'm starting to see the issue. We're asking for gourmet results with outdated equipment.
Exactly. And get this, there's this almost shocking quote in the paper. Surprisingly, there have been relatively few efforts aimed at enhancing MLPs themselves.
So everyone's focused on the fancy kitchen decor, but ignoring the most important part.
Precisely. And that's where things get really interesting. They're bringing in this super elegant concept, the Kolmogorov-Arnold representation theorem.
Uh-oh, big words incoming.
Don't worry, no math lectures here. In essence, it says you can build any complex function, no matter how wild, by combining simpler ones. Think Legos.
Okay, I can work with Legos.
With enough of the right pieces, you can build anything. And that's the potential of CANs, Kolmogorov-Arnold networks. Incredible efficiency, fewer parameters, meaning faster learning, and potentially smarter AI.
So we're trading the basic stove for a high-tech, infinitely flexible Lego set.
You got it.
This is already blowing my mind. But there's always a catch, right?
Of course, that's for part 2.
All right, you've teased these amazing Lego-like cans that can revolutionize AI, but there's a but in there somewhere, right? Spill it? What's the catch?
Well, like with all things promising in AI research, there are a few hurdles. And this paper, to its credit, lays them out pretty clearly. They call them challenges, 3 of them to be precise, holding back cans from, taking over the world.
Okay, so what's tripping up these super efficient AI Lego sets? Lay it on us.
Challenge number 1.
Yeah.
The base function problem. Remember those simpler functions are Lego blocks. Turns out the kind traditionally used for cans, called B-splines, they don't play well with the modern world of GPUs.
GPUs, those super fast processors everyone's after these days.
The very same. It's like trying to run the latest, most amazing video game on a computer from the Stone Age. The hardware just can't keep up, even if the game itself is revolutionary.
So we're bottlenecked by compatibility issues. Got it. What's hurdle number 2?
Inefficiency. And this one, it's kind of a logistical nightmare. Imagine a factory, right? But every single worker needs a completely unique set of tools for every single task they do.
Talk about chaos. The organizational overhead alone would be insane.
And that's what scaling up traditional cans is like. It's incredibly complex, demands a ton of computing power, not exactly practical if we want AI everyone can use.
Ouch, okay. 2 down, 1 to go. What's the final challenge they highlight?
This one's called weight initialization. A bit more technical, but bear with me. Think of it like, building a tower of blocks. But these blocks are really sensitive. Weight initialization, it's about getting those blocks balanced perfectly right at the start.
Because if that first layer is off, the whole thing is doomed.
Exactly. Even a slight wobble, and the whole tower can collapse as you build higher. In cans, this means the learning process becomes unstable. The AI might not learn effectively, or it might learn the wrong things, which is even worse.
Okay, so we've got clunky tools, an inefficient factory, and a wobbly tower of blocks. No wonder cans haven't quite lived up to their full potential yet.
A very astute observation. But that's what makes this paper and the research it presents so compelling.
Yeah.
Because they didn't just point out the problems, they actually went ahead and tried to fix them.
Because no good story ends with a pile of unusable Legos. They found solutions.
That's for the next part of our deep dive.
Okay, so they laid out the Kate hand challenges, the clunky tools, the chaotic factory, the shaky tower. What did this paper propose to actually address those?
This is where it gets really elegant. They introduce KT, their solution, and it tackles each of those challenges head-on very directly.
Okay, hit me with it. How does KT save the day?
First, they ditched those clunky B-spline tools. Instead, they used something called rational activation.
Catchier name at least, but what does it do?
It's all about compatibility with modern hardware. Rational functions, which is what they switched to, are much friendlier to GPUs. It's like, instead of forcing a square block into a round hole, you're finally using the right shape.
Ah, so smoother, faster processing. But did they quantify the improvement at all?
They did. In their testing, this one change led to a 9.3 times speed improvement. That's huge.
Wow, that's not just a little tweak, that's a fundamental shift. Okay, what about the efficiency problem? How'd they reorganize that factory?
That's where Group KN comes in. Instead of every worker needing their own unique tools, now imagine workers with similar tasks grouped together, sharing specialized tools.
So more like departments within a factory, each with its own expertise.
Precisely. Cuts down on redundancy massively. They found this grouping significantly reduces the number of parameters needed, which means faster training, less resource-intensive overall.
Elegant and practical. I like it. Now, for the grand finale, the weight initialization issue. How do you stabilize that tower of blocks?
They call their approach variance-preserving initialization. It's about ensuring those initial building blocks, those first few layers, are incredibly stable from the get-go. Imagine instead of just blocks, they're using like perfectly level foundation stones.
Ah, so the structure is sound right from the start, no wobbling as you build higher.
And that's what they found. The learning process becomes much more stable even as the model gets more complex.
So they've streamlined the tools, organized the factory, and stabilized the foundation. But does it actually work?
That's the real test, right? And they tested KT on a whole bunch of benchmarks. Image recognition, even more complex stuff like semantic segmentation. Basically teaching AI to see and understand images like we do.
Give us the good stuff. How'd it perform?
Across the board, KT beat out traditional models, especially at smaller sizes.
So more efficient and more effective. That's a winning combination.
Exactly. One really impressive result on ImageNet, which is like the gold standard data set for image recognition. Their KTS model, even at that small size, outperformed the well-established DATS model by 2.4% in accuracy.
I know those percentages might sound small to some, but in the AI world, that's huge.
It's the difference between good and groundbreaking a lot of the time.
So we're on the brink of an AI revolution here.
It's still early days. The authors themselves acknowledge that. There are limitations with KT. Speed, while greatly improved, can still be better. And stability, while better than previous cans, can still be a bit finicky.
So not a perfect AI superhero yet, but definitely showing some serious potential.
Exactly. And that's what's so exciting about this field. This paper, it's really just the beginning. A whole new set of tools, a new way of thinking about how we build AI. Who knows what incredible applications are just around the corner?
This has been a wild ride. We've gone from the limitations of current AI to these powerful but flawed cans to KT and its potential to rewrite the rules.
And the best part is, this is ongoing research. Who knows what breakthroughs are just on the horizon?
If you're as intrigued by KTs as we are, you're in luck. We've got links to the paper along with some other fascinating resources in the show notes. Be sure to check them out.
And don't forget to subscribe to the Deep Dive so you don't miss out on our future explorations into the cutting edge of AI and beyond.
Until next time, keep those minds curious, and we'll see you in the next Deep Dive.
Ever get that feeling, like when you're using a search engine?
Yeah.
And it's like, it's just guessing at what you mean.
Yeah, definitely. Happens all the time.
Like you're trying to find something specific, that one article.
Yeah.
But all you get is like clickbait and stuff that's not even relevant.
Totally. And it all comes down to how computers understand what we're saying, It's not perfect.
It's like they don't get the nuances, the context of our words. We're not speaking binary code here.
Exactly. And that's what makes this new research paper we're diving into so interesting. It's all about GINA embeddings v3.
And this is about basically bridging that gap, right? Between how we think and how machines process language.
It's about teaching machines to really grasp the essence of a text. A single sentence, an entire research paper.
It's like almost magic, right? Turning words into like this code that algorithms can use.
It is pretty amazing. It's the magic of text embeddings. Think of them like little digital messengers carrying the meaning from our language to the computers.
Okay, I kind of get that, but break it down for me a bit more. So you're saying a text embedding can take like Shakespeare's Hamlet,
right,
and turn it into something an AI could understand, even with all the wordplay and stuff.
Well, maybe not directing a play just yet, but you're on the right track. The real win with text embeddings is how they help machines understand the core message, the context. Like, imagine searching for research papers about, say, climate change. Text embeddings could help a search engine go beyond just matching keywords and actually find papers that are about that specific thing you want, that relationship between climate change and whatever else you're looking for.
So it's like giving the search engine, what, reading comprehension skills or something?
Exactly. It's about understanding, not just recognizing words. And it gets even trickier when you think about all the languages out there. Building a model for English is one thing.
Right.
But what about Mandarin, Arabic, Spanish? Traditional models really struggle with that.
Not to mention, like, the way we use language changes depending on the situation, right?
For sure.
A tweet's different from a news article, which is
Well.
different from, like, a scientific paper.
Yeah.
It's a lot to ask of one model to handle it all.
Absolutely. And that's where Gina Embeddings v3 comes in. What they've done is create a model that's efficient, adaptable across languages and tasks, and get this, they did it without using those massive large language models.
Wait, hold on. No giant LLMs? You mean the ones that are supposed to be, like, the key to everything AI?
The very same. And while they're powerful, they're also expensive, and not everyone has access to that kind of computing power. Gina Embeddings v3 takes a different approach, a more streamlined one.
So does that mean this tech could be more accessible then? Not just for people with supercomputers?
Exactly.
That's huge. But how'd they pull it off? What's going on under the hood of this model?
So it's like they found a way to build, like, a race car. It's as fast as a jet, but, way more practical to actually use every day. That's a great way to put it. And one of the key things they tackled was, like, those times when you ask a search engine a perfectly clear question?
Yeah.
And it just gives you completely irrelevant results.
Oh, all the time. Like, I'm searching for vegetarian recipes and it's all just meat because I use the word burger.
Exactly. Those are often because of what we call retrieval failures. Basically, the model is getting tripped up by something, some linguistic quirk, or it's not getting the real meaning.
It's like those optical illusions, right?
Yeah.
Where your brain kind of gets tricked, even though the information is right there.
Perfect analogy. And with Gina Embeddings -v3, they found a way to deal with that. They call it patching retrieval failures. And it involves some really creative use of synthetic data.
Synthetic data? So they're like giving the model a crash course in all the ways language can be messed up, like training it to spot those traps.
Precisely. They expose it to all these potential problems during its training.
That's one smart patch, I guess. But
Yeah.
that can't be all, right? What else is making this Gina Embeddings v3 so special? So they made it tougher. Okay. But it's going to be efficient too, right?
Right, and that's the other thing. They actually managed to make the embeddings themselves smaller without losing accuracy.
What? Really? How'd they do that?
They used a technique called Matryoshka representation learning, MRL.
MRL, okay.
Yeah, think of those Russian nesting dolls.
Oh, right.
Smaller dolls inside bigger ones. It's kind of like that. Compressing the information into smaller packages.
Like those, what are they, space bags? For your clothes, but for information.
Yeah, exactly. All the good stuff, but taking up less space.
Brilliant. But did it actually work? Like when they tested it, did it actually perform well?
It did, yeah. They used this benchmark called MTE. It's like the Olympics for this kind of model.
Okay. High stakes.
Yeah, and it tests them on a whole bunch of different tasks in English and other languages too.
So how'd it do?
Really well, especially on those multilingual tasks. Consistently beat out bigger, more complex models.
Wow. That's really something. So what does it all mean then? Besides just, winning the AI Olympics?
It's about more than that. This multilingual ability, it could change how we access information. Imagine if language wasn't a barrier anymore.
Right. Yeah.
You could be researching anything from anywhere in the world and understand it perfectly.
That's the dream, isn't it? Breaking down those barriers.
Absolutely.
Well, this has been amazing. A real eye-opener.
It's a fascinating field. Lots of exciting developments happening all the time.
Thanks for taking us on this deep dive into Gina Embeddings -v3. It's definitely given us all a lot to think about.
Anytime. Thanks for having me.
And for everyone listening, remember, the future of language is closer than you think. Until next time. All right, so get this. Today, we are diving deep into, you guessed it, AI.
Of course.
What else is new, right? But specifically,
That's
these massive language models that, let's be real, everyone's talking about.
Right.
And, you sent us this research on ferret. At least that's what they're calling it.
Yeah. Ferret. Catchy.
I mean, it's not exactly catchy, the full title, ferret. Federated full parameter tuning at scale for large language models. It's a bit of a mouthful.
Yeah, I'll give you that. Not exactly something you'd put on a bumper sticker or anything.
Definitely not, but trust me on this. This is seriously interesting stuff.
What I find really cool about this paper, though, is it doesn't just tell you what ferret is. It really digs into the why it matters. It's not just another algorithm. You see, it's tackling a really fundamental problem in AI right now.
Okay, so for those of us who, haven't dedicated our lives to AI research, break it down for us. What's the problem we're talking about?
So imagine, right, you're trying to train this super smart AI.
Okay, got it. AI, check.
But the data it needs to learn is scattered everywhere, like literally everywhere. Phones, laptops, servers, you name it. You can't just scoop it all up into one giant database.
Because of privacy issues.
Huge one. Think healthcare records. You can't just go dumping all that sensitive data into one place and call it a day.
That's a lawsuit waiting to happen.
Exactly. Privacy is paramount here, and that's a major, major roadblock Ferret is trying to get around.
Okay, so how does it actually work? They were talking about first-order methods and zeroth-order methods. I'll be honest, I had to do a little Googling to remind myself what those even were.
No shame in that. It's complicated stuff.
It really is.
So picture this. You're trying to navigate a new city, yeah? A first-order method is like having this super detailed map, every street, every little alley, every landmark, it's all there, really precise, but that map is going to be huge.
Okay, I'm with you so far.
Now, zeroth order is more like, following your nose, sniffing out clues, getting a feel for the layout, but you don't have that complete picture right in front of you. It can be faster, but maybe not as accurate.
So Ferret, it's like combining those two, like using a compass and a few landmarks instead of the whole map of the city.
You got it. That's where this whole shared randomness thing comes in. It sounds kind of weird, right? Using randomness when we're talking about such a precise field.
Totally.
But that's part of what makes Ferret so clever. Imagine those spot the difference puzzles.
Oh, okay. I see where you're going with this.
Right. So if we both start with the same random picture, we only need to tell each other the T and Y differences to figure out what each other's full image looks like. We don't have to send the entire thing back and forth.
So instead of setting a whole AI model between devices, which would be like super data-heavy Ferret, just sends these little differences based on that shared randomness.
Exactly. Way more efficient for bandwidth, way better for privacy. It's a win-win.
That's seriously clever.
And the best part, it's not just clever, it actually works.
Okay, so we know Ferret is efficient. We know it's accurate. But what does this all actually mean in the real world? The paper mentioned something about it being really useful when you've data in lots of different places, and privacy is super important. What did they have in mind there?
Tons of applications, really. Healthcare is a big one. Think about it with Ferret. You could train these really powerful AI models on sensitive patient data, but you wouldn't actually have to move that data from individual devices.
So like hospitals in different places could work together, but without actually sharing their patients' records.
Exactly. They could build a way more accurate diagnostic tool using all their data combined, but keeping everything private. It's groundbreaking stuff.
That's wild. Like a whole team of doctors collaborating on a diagnosis without ever actually seeing each other's patients' files.
Right. And it doesn't stop at healthcare. Imagine what this could do for finance. You could have AI looking for patterns in financial data across thousands of devices, giving people super personalized advice or detecting fraud way faster.
All without anyone ever actually seeing your bank statements except you.
Exactly. So it's not just about making AI more efficient. It's about making it more responsible, too, giving people more control over their data.
It's almost like democratizing AI, in a way, giving smaller companies and even individuals the ability to do more with it.
And what really gets me is how Ferret pulls this off.
Yeah.
It's not just about shrinking the amount of data. It's about choosing the right information, the important bits, and sharing those in a clever way. There's this whole mathematical underpinning to it. They're talking about low-dimensional spaces, which sounds kind of complicated, I know.
Yeah, I'll admit that one went over my head a little.
Yeah.
What's the deal with those?
Think of it this way. Say you're trying to tell someone where a city is on a map, right? You could give them the latitude and longitude, those two coordinates. But what if you only needed to tell someone where it was within a specific country?
You wouldn't need to be as specific, right?
Exactly. You could use a simpler system, fewer coordinates, because you're working within a smaller space. That's kind of what Ferret does. It uses these low-dimensional spaces to describe complex data more efficiently. It's like finding the essential landmarks, the key pieces of information, so you don't get bogged down in unnecessary details.
So it's like a shortcut, but without losing any of the important stuff.
Right. And when you combine that with everything else, the first order and zeroth order stuff, the shared randomness, it's like ferrets pushing the boundaries of what AI can even do.
It's kind of mind-blowing when you think about it, but it's all theoretical, right? Did they actually test this thing out? Did it actually work?
Oh, yeah. They put it through its paces. They did all sorts of experiments comparing ferret to other cutting-edge methods using benchmark data sets and everything. And the results are really something.
So they actually put it to the test. What'd they find? Spill the tea.
Okay, get this. Ferret consistently performed as well as, or even better than, those other methods.
No way.
Yeah. And they used way less bandwidth, too. It's a huge win for privacy and for efficiency.
Okay, so we've covered a lot of ground here. Ferret, it's efficient, it's accurate, it could totally change how we use sensitive data and AI. But like, for folks out there who aren't, AI wizards, why should they care? What's the big deal?
That's the question, right? This isn't just some abstract research that's could actually change our lives. Imagine, your phone could give you personalized health advice based on data from millions of people, but it never actually shares your info.
Or what about those apps that are always trying to sell you stuff? They could get way better at recommending things you actually want, but without knowing all your deepest, darkest secrets.
Exactly. Ferret opens up all these possibilities for AI that's both powerful and respects our privacy. It's like having your cake and eating it, too,
So it's not about making our devices smarter for the sake of being smarter. It's about doing it in a way that actually benefits us without all the downsides.
Right. And this research, it focused on language models, sure, but the ideas behind Ferret, they could apply to other areas of AI, too. Computer vision, robotics, who knows what else.
It's like they've created this whole new toolkit for building AI, one that actually cares about doing things the right way.
Exactly. It's not just about what we can do, it's about what we should do.
Well said. This has been a wild ride. We started with this super complex research paper, and now we're talking about the future of AI and what it means for all of us.
And that's what's so exciting about this field, right? There's always something new to discover, something that could change everything.
Totally. Huge thanks to you, dear listener, for sending in this research. Keep those brain busters coming. And until next time, keep exploring, keep learning, and keep that curiosity burning.
See you in the next deep dive. All right, so today we are diving into some really cutting-edge AI stuff.
Yeah, definitely cutting edge.
We're talking brand new research.
Hot off the press. Groundbreaking stuff.
And we always hear about AI becoming more and more capable.
Right.
But this research really gets at a challenge that has puzzled computer scientists.
Yeah, it's the reasoning problem.
Yeah.
How to get AI to not just work with data, but to think logically and make inferences and deal with uncertainty.
Right, like the real world.
Exactly like how we think. And this paper on the diagram of thought says it's made a major leap forward.
Diagram of thought. Okay, I gotta be honest, when I first saw that title, I was intrigued.
Yeah.
But also a little intimidated. It's a big concept. How can we diagram thought?
It's a bold title, and it's a bold idea. It's a whole new way of modeling how AI processes information to solve problems.
Right.
Yeah.
Okay, I am very interested now.
Yeah.
So tell me more. What's the core idea?
So the core concept is this: older AI models used linear step-by-step reasoning.
Okay.
But diagram of thought, or DGOT, uses a more flexible kind of web-like structure.
Web-like, so less like a straight line, more like a mind map or something.
Yeah, exactly. They use what's called a directed acyclic graph, or a DAG.
Okay.
But the important thing is that this DAG structure lets the AI explore many different paths of reasoning at the same time.
At the same time.
And it can backtrack if it needs to and refine ideas as it goes, kind of like how our brains work.
So instead of just following one line of thinking, it can jump around, test different paths, and change its mind.
Exactly.
That's a huge difference from how we normally think about AI.
Yeah, it is. And this is a potential game changer.
Okay, now I'm really interested.
Okay.
So let's unpack diagram of thought a bit more.
Okay.
What are the key parts of this?
So the DGOT model has three main roles: the proposer, the critic, and the summarizer.
Okay, those are really interesting. Each one has a specific job, I'm guessing?
Yeah, exactly. Think of the proposer as the idea generator.
Okay.
Its job is to put forward potential solutions or reasoning steps to explore all the possible avenues.
So like the brainstorming phase, throwing spaghetti at the wall and seeing what sticks.
Exactly. Now, the critic comes in.
Oh, okay.
Its role is to evaluate those proposals. Are they logical? Do they contradict any known information? Are there any flaws in the reasoning?
So it's like that inner voice we all have, double-checking our work, making sure we don't make any leaps in logic. Except hopefully the AI's critic is a little less prone to self-doubt than mine.
Let's hope. And finally, we have the summarizer. Once the proposer has tossed out ideas and the critic has had its say, the summarizer steps in to organize the validated septs, the ones that have stood up to scrutiny, into a final coherent explanation.
It's like taking all those brainstorm notes, crossing out the dead ends, and then composing a clear, concise answer.
Precisely. And what's fascinating is that this proposer-critic summarizer framework, it's not just some abstract computer science concept. It actually maps surprisingly well onto how we humans approach problem solving. We generate ideas, we critique them internally or with others, and then we synthesize our thoughts into conclusion.
So you're telling me I've got a mini DOT model running in my brain right now? That's both impressive and a little concerning. But okay, this all sounds great in theory, but what are the practical implications?
Yeah.
What makes this DOT approach a potential game changer?
Well, for one, it has the potential to make AI significantly more efficient.
Oh, okay.
Think about it. By building that critical evaluation directly into the model, into the critic role, DOT allows the AI to identify and discard bad ideas early on, without wasting time and computational power exploring every single dead end.
So it's like having a built-in bullshit detector.
Yeah.
No more endless loops of illogical conclusions.
Exactly. It streamlines the learning process, making the AI more adaptable, more able to course correct on the fly. And that leads us to another key advantage: more human-like reasoning. Because DOT mirrors the non-linear iterative way that we humans actually think, it could allow AI to tackle complex, open-ended problems that have traditionally stumped more rigid systems.
So instead of being limited to pre-programmed rules, the AI can adapt, think on its feet, even get creative in its problem solving. That's a pretty big deal, right?
It is. Imagine an AI that can brainstorm like a scientist, exploring multiple hypotheses simultaneously. Or an AI that can grapple with the nuances of ethical decision-making in a way that considers different perspectives and potential outcomes.
Okay, now you're talking. This is where things get really interesting. But before we dive into all the mind-blowing possibilities, I have to ask, how did the researchers even begin to build this DOT model?
Yeah.
What's the foundation of this whole approach? Because it sounds pretty mathematically complex to me.
You're right. There's some heavy-duty math underpinning all of this. In fact, the researchers used a branch of mathematics called topos theory to formalize the DOT framework.
Topos theory. All right, now we're getting into territory where I might need a guide. Can you break down for us, in layman's terms, what this topos theory thing is all about?
Topos theory, it sounds like something out of a high-level math textbook.
It kind of is. But
Yeah.
you don't need to be a math whiz to get the idea. Basically, topos theory is a way to describe spaces and relationships, but in a really abstract way.
And how does that apply to AI, to this diagram of thought? So imagine the DOT model with its web of thoughts and connections as a kind of space. Well, topos theory gives us the tools to make sure that space makes sense logically, to make sure there are no gaps or contradictions in how the AI connects ideas. It's like a blueprint for a building.
So it makes sure that AI's reasoning is really solid.
Exactly.
Wow, that's really impressive. But let's think about the future for a minute.
Okay.
Where do we go from here? What could we use this for in real life?
There are so many exciting possibilities. Imagine AI scientists looking through tons of medical research to find new drugs or AI assistants, helping policymakers understand complicated things like climate change.
So it's like they're giving us these superpowered thinking partners, AIs that don't just process information, but actually reason about it in a new way.
Yeah, and because DOT is more like how humans think it could be used in creative fields too.
Oh, really?
Like imagine AIs working with artists to come up with new ideas, or AI writers creating stories with really interesting characters.
That's amazing. But we've talked about the good stuff.
Right.
Are there any risks we should be thinking about as this technology gets more advanced?
It's always important to be careful with powerful technology.
For sure.
We have to make sure these AI systems are developed responsibly with safeguards in place.
Absolutely. Well, I think that's a lot for our listeners to think about today.
Yeah, definitely.
This diagram of thought research is really interesting. It gives us a peek into the future of AI.
Yeah, it's exciting to see where it goes from here.
Yeah. And I guess a final thought for everyone. If AI can learn to think in diagrams like this, could it actually change how we solve problems in the future? Something to think about. Thanks for joining us for this deep dive into Diagram of Thought. Until next time, keep those minds curious. Welcome back to The Deep Dive. Today, we're diving into your research on how to choose the perfect AI for visual questions. You're really thinking ahead of the curve on this one, which is awesome.
It's a hot topic, that's for sure.
Mm.
We're talking about vision language models, or VLMs AI, that can understand both images and text.
Right, so instead of just asking Google to show me pictures of birds, you could show your phone a picture and ask, what kind of bird is this? And the AI could actually tell you. But here's the thing. You didn't just want to know which AI can do that. You want to know which one does it best. And more importantly, which one is best for your specific needs. Am I right?
Spot on. And that's what makes the research you send over so fascinating. It's not about declaring a single VLM winner, but about understanding their strengths and weaknesses.
Okay, so let's unpack that. You've clearly done your homework on this, which I love. But I know from experience that even the most fascinating research papers can sometimes feel like they were written in a different language.
It's true. A lot of the time, traditional AI evaluation metrics don't really capture how well a VLM would actually perform in the real world.
Right.
It's like judging a fish on its ability to climb a tree. Right?
Exactly. And that's where this research comes in. They actually tried to evaluate these VLMs in a way that's closer to how humans would assess them. So instead of just spitting out technically correct answers, they were looking for AI that could actually understand the nuances of visual questions and give you an answer that makes sense in context.
And that's key because, as you pointed out, not all VLMs are created equal. They have different strengths, just like different tools in a toolbox.
You wouldn't use a hammer to tighten a screw, right?
Precisely. And the research actually highlights some surprising examples of this. For instance, one VLM might be amazing at understanding images of nature, but struggle when it comes to interpreting charts and graphs.
Which is wild. It's like some AI are nature enthusiasts and others are more like data analysts. But the researchers found that even VLMs from the same company can have wildly different strengths and weaknesses.
That's why this research is so valuable. It gives you a framework for figuring out what you really need the AI to do, rather than just looking at which one scored highest on some arbitrary test. It's about finding the right tool for the job.
So, for our listener out there, let's say they're building an app. Let's say you're building an app that helps people identify plants in their backyard. You snap a picture, ask the app, what kind of plant is this? Is it poisonous to my dog? That kind of thing. What kind of VLM strengths would you be looking for in that scenario?
In that case, you'd want a VLM that's particularly good at understanding images of nature, obviously, but you'd also want one that's fast and efficient, especially if you want the app to work offline or on a phone without draining the battery. You might even need it to be good at understanding spoken language, not just text.
Right, because someone might be using your app while they're out on a walk with their dog. They don't want to have to stop and type out a whole paragraph.
Exactly. Now compare that to an app that helps financial analysts interpret stock charts. Suddenly, you need a VLM with a completely different skill set. It needs to be able to understand complex visual data, recognize patterns, and maybe even have some knowledge of economics and financial terminology.
Okay, so we've established that different VLMs have different strengths, but the research you sent also dives into this distinction between closed and open models. Honestly, this is the part that always makes my head spin a little, so I'm hoping you can break it down for me, Andy, for our listener who's just as curious about this stuff as I am.
Of course. In the simplest terms, a closed model is like a fancy pre-assembled kitchen appliance. You press a button, and it does its thing, but you can't really tinker with the internal workings. A great example of this is Google's Gemini, incredibly powerful, but you access it through an API.
Hold on, pause for a second. I know we're trying to keep things ELI 5, but can you quickly explain what you mean by API for those who might not be familiar with the term? I always think of it like ordering takeout. I tell the restaurant what I want, they send me the food, and I don't need to know how they made it in the kitchen. Does that track?
That's a great analogy.
Yeah.
An API, or application programming interface, is essentially a messenger that allows different software systems to talk to each other. So, with a closed model like Gemini, you're sending your requests through this messenger, and Google handles all the complex processing behind the scenes.
Got it. So closed models are like the set it and forget it option, but you don't get to see how the sausage is made. What about open models then? Are those more like building your own computer?
Exactly. Open models are like a set of blueprints. You can download the code, see how it works, and even modify it to suit your specific needs. And that brings us to one of the key advantages of open models that the research highlights: customization. You can fine-tune them to become incredibly good at a very particular task, something that's much harder to do with closed models.
So it's kind of like the difference between buying a pre-made suit and getting one custom tailored. The pre-made suit might be perfectly fine, but the custom one is going to fit you like a glove. But in the AI world, are there ever times when one approach is objectively better than the other? Or is it always going to depend on the specific needs of the project?
That's the million-dollar question.
Yeah.
And honestly, there's no easy answer. The research did find that, in many cases, closed models like Google's Gemini tend to outperform open models in terms of raw power. But
There's always a but, isn't there? It's never as simple as, this one's the best, end of story.
right, if it were that easy, everyone would be using AI and we wouldn't need this deep dive. But here's the thing about open models. They have some serious advantages that go beyond just raw performance.
Like being able to customize them, which you mentioned earlier. That's a big one.
Absolutely. But the research also points to another big factor, especially for you: data privacy.
Okay, yes. That's huge E for me. I'm all about keeping my data close to the vest, as they say.
And I can see why that would be a major consideration when choosing between a closed model, where you're essentially sending your data off to a third party, and an open model, where you have more control over where your data goes and how it's used.
Exactly. It's like the difference between handing your diary over to someone else to read versus keeping it locked up in a safe. But okay, let's say data privacy wasn't a concern and you were purely focused on performance. Did the research actually pit these VLMs against each other to see who comes out on top?
They did, and this is where it gets really interesting. The research actually tested a bunch of different VLMs across a range of tasks and domains like identifying objects and images, answering questions about those images, even understanding the sentiment of text within an image, and they ranked how well each model performed.
So do you have to become a data scientist just to figure out which VLM is right for you? Because I'll be honest, those charts in the research paper were pretty intense.
That's the beauty of it. You don't. This research does a lot of the heavy lifting for you. In their conclusion, they highlight a few VLMs that stood out as particularly strong contenders, depending on your priorities.
Give it to me straight. Which ones should I be paying attention to?
Well, if you're after top-of-the-line performance and budget isn't a major constraint, Gemini 1.5 Pro really impressed in the research. It consistently ranked highly across a variety of tasks.
So Gemini is still a strong contender, even with the data privacy trade-off. But what if you are on a tighter budget or need something that's maybe a bit more lightweight?
Then Gemini 1.5 Flash might be worth looking at. It's designed to be a more efficient version of the Pro model, so it might be a good fit if resources are limited. And for the open source fans out there, the research actually found that Intern VL 2.8D, remember that one, held its own against some of the bigger closed models, especially when it came to certain tasks.
It's like the little engine that could. So to sum it all up for our listener, who's probably just as excited about the possibilities here as I am, when it comes to picking the perfect AI for visual questions, there's no one-size-fits-all answer. It's all about finding the right tool for the job. And thankfully, this research gives you a head start on figuring out what that tool might be.
Perfectly said. I think this research really highlights the importance of understanding not just what these ELMs can do, but also how they do it and what their limitations are.
Absolutely. It's about making informed choices, not just chasing the shiniest new AI toy. But speaking of shiny and new, this field is evolving so quickly. What do you think this means for the future of visual question answering? Are we going to reach a point where one AI can truly do it all? Or will we always need a variety of specialized tools?
That's the million-dollar question. It's hard to say for sure, but personally, I think there's always going to be a need for specialized AI, even as these models become more and more powerful. Think about it this way.
Right.
Even with all the incredible advancements in medicine, we still have specialists for different parts of the body, right?
Right. You wouldn't go to a cardiologist for a broken bone.
Exactly. And I think we'll see the same thing with VLMs. We might have general-purpose models that are great for a wide range of tasks, but there will always be a need for AI that's specifically trained and optimized for particular domains or use cases.
And that makes a lot of sense. It's like having a team of expert AI consultants at your fingertips. Well, this has been an absolutely fascinating deep dive. Huge thanks to you, as always, for walking us through this complex topic. I feel like I've learned a ton, and I'm sure our listener has too.
It was my pleasure. Always exciting to talk about this stuff with someone as enthusiastic as you are.
And for our amazing listener out there, we'll have links to the research we discuss, plus some other resources in the show notes so you can keep exploring this topic on your own. And hey, while you're there, let us know what you're using VLMs for. Maybe it'll inspire our next deep dive. Until then, keep those brains buzzing, and we'll catch you on the next episode of The Deep Dive. Ready for a deep dive? Today we're tackling how AI is learning to write better code. And let me tell you, it's way more interesting than watching paint dry.
Definitely more dynamic.
Right. So imagine you're teaching someone to bake, like the perfect sourdough. You wouldn't just say, yep, good bread, or, oh, that's a brick, not a loaf. You'd give them specific feedback, like, need it a bit longer, or watch that oven temp.
Makes sense. You need those pointers to improve.
Exactly. And it turns out AI needs that same kind of guidance when it's learning to code. But here's where it gets really interesting. Giving feedback to an AI is a whole lot more complex than you might think, which is what makes this paper, Policy Filtration in RLHF to Fine-Tune LLM for Code Generation, so fascinating.
It really digs into the weeds of how we train AI to code. Right now, the leading method is something called RLHF, which stands for Reinforcement Learning from Human Feedback.
Okay, so humans are involved in this AI training boot camp.
Absolutely. Basically, humans grade the code the AI generates, kind of like those coding challenge websites. The better the code, the higher the grade, and the AI uses that feedback to get better over time.
Sounds pretty straightforward, but I have a feeling it's not that simple.
You're right to be skeptical. There's actually another layer to this whole process, this reward model the paper keeps mentioning.
Another AI. Now you're just messing with me.
It sounds like something out of a sci-fi movie, right? But it's actually pretty common in AI training. Think of the reward model as an AI teaching assistant. Its job is to assess the code that the student AI is writing and give it a preliminary grade.
So it's like an automated code reviewer.
Exactly. But here's the catch. Judging code quality, even for humans, can be subjective. There are often multiple ways to solve a problem. Now imagine an AI try to make those judgment calls, especially when the tasks get super complex. Even the best human coders sometimes disagree on what makes code good.
So we're trusting this AI assistant to grade the student AI's work, but it might accidentally mark down a perfectly good solution or give a passing grade to something that's actually a mess.
That's the risk. And what this paper highlights is that these reward models, as clever as they are, have a particular quirk. They're much better at assessing code at the extremes.
Extremes.
Like code that's utterly brilliant, super elegant. The reward model usually nails those assessments. Same with code that's a complete train wreck. It can easily flag that. But it's that middle ground where the code is okay, but could be better. That's where the reward model starts to falter. It's like it's less sure of itself when the answer isn't a clear-cut yes or no.
It's like in figure 1, right? I'm looking at the graph now, and it shows that the reward model's accuracy dips when the code gets a moderate rating. It's like it's struggling with the nuances.
Bang on. And that's a big deal because in the real world of coding, not everything is black and white. There are so many shades of gray, different approaches, different styles. That's the kind of complexity the AI needs to master.
Okay, so if the AI's teacher, the reward model, isn't always giving the most accurate feedback, how can we expect the AI to learn effectively? I feel like we're back to square one. So it sounds like we've got this AI student eager to code, but the teacher, the reward model, isn't exactly giving out straight A's for guidance. What's the solution here?
It's like imagine handing a kid every single comment scribbled on their homework. Some feedback is just more helpful than others. That's the heart of this paper. What if we could, filter the feedback so the AI is only learning from the most relevant stuff?
Giving the AI noise-canceling headphones, but instead of blocking out sound, they're blocking out unhelpful coding advice. I like the way you think. But seriously, how do you filter out the noise in AI training?
The researchers call their approach PFPPO, which stands for Policy Filtration for Proximal Policy Optimization. But honestly, the name is a mouthful.
Yeah, let's stick with filtering out the noise. So how does it actually work?
Okay, so remember our reward model, the AI teaching assistant. PFPPO basically helps the AI zero in on the feedback where the reward model is most likely to be accurate. It learns to tune out the feedback where the reward model tends to get a little, shall we say, uncertain.
So it's like, okay, pay attention to the amazing job and the needs major improvement feedback, but maybe don't sweat the mess so much.
You got it. But here's where things get super interesting. The paper points out that it's not just about keeping the best examples. Sometimes showing the AI good code right alongside bad code side by side can be even more effective.
Wait, really? That's counterintuitive.
Yeah, it's like telling a kid, look, this cookie's perfect because it's golden brown, but this one is a bit doughy because we took it out of the oven too soon. Sometimes seeing that contrast makes it click.
Ah, I see. It's all about understanding the why behind the what.
Exactly. And that's why this PFPPO approach is so clever.
Yeah.
It's tapping into that same kind of contrast-based learning that we see in humans.
I'm loving this. We're not just talking about AI, we're talking about the very essence of learning. But before we get too philosophical, let's get back to the nitty-gritty. The paper didn't just talk about this approach in theory, they actually put PFPPO to the test, right? So did they throw every coding challenge and their mother at this AI to see what it could handle?
Pretty much. They use 3 different sets of coding problems, and one of them, the Elite Code Contest benchmark, that's the real deal.
Leet code. Like those coding competition problems that even experienced programmers agonize over.
The very same. We're talking about complex algorithms, data structures, the whole shebang.
Okay, so why use these crazy hard problems? Why not start with something simpler?
Because if PFPPO could hold its own against these kinds of challenges, we'd know it was something truly special. It's like testing a new race car. You want to see what it can do on a real track, not just a practice course.
So how to do? Did this AI speed demon cross the finish line?
Hold on to your hats, because PFPPO didn't just finish the race, it blew the competition out of the water. Table 2 in the paper shows it all place. PFPPO consistently outperformed the other methods, and get this, it really excelled on those leak code problems.
That's incredible. But let's shift gears for a moment. I'm not a coder, so why should I care about any of this?
That's the beauty of it, even if you never write a single line of code in your life. This breakthrough has the potential to change everything about your digital experience.
Really? How so?
Think about it. Faster software updates for your favorite apps, fewer glitches and crashes, new features that seem like they were tailor-made for you. That's the power of better code-generating AI.
Okay, now you're speaking my language. So it's not just about making AI a better coder, it's about using AI to improve the technology we all rely on every single day.
Absolutely. And this is just the beginning. Imagine AI assistants that can help you debug your own code or even write simple programs for you. Remember those frustrating error messages that used to make you want to throw your computer out the window? Those might become a distant memory.
Now that's a future I can get behind.
And this whole journey started with a simple question: how do we give AI the most effective feedback? It turns out that question has implications far beyond the world of coding.
It makes you think, doesn't it? This idea of filtering out the noise and focusing on what truly matters for learning. Maybe AI can teach us a thing or two about how to be better learners ourselves.
Now, there's a thought-provoking idea. By studying how we train AI, perhaps we can unlock new insights into human learning and education. It's a fascinating frontier, and it just goes to show exploring the cutting edge of technology often leads to unexpected discoveries about ourselves and the world around us.
It's a powerful reminder that the most exciting discoveries often happen at the intersection of different fields. Who knew that AI coding could shed light on the mysteries of the human mind? Well, that's all the time we have for today's deep dive, but remember, the exploration never truly ends. Keep those minds curious, and we'll catch you in the next episode. Ever get frustrated with your voice assistant? Like when it's just not getting it?
Yeah, tell me about it.
Like, you know what you mean?
Yeah.
But it's so stuck on those literal words, you know?
Right.
Well, get ready to have your mind blown, because today's deep dive is all about AI that's learning to understand sound like we do.
It's true.
Meaning, the context, even emotion.
Yeah.
The whole sonic enchilada.
The whole 9 yards. We're diving into the world of zero-shot audio classification.
Okay.
Or as it's known in the biz, ZSAC.
Yeah.
The research paper that you shared focuses on ReClep.
Okay.
It's a new model that's causing quite a stir in the AI community.
Okay, zero-shot audio classification. It sounds kind of like something straight out of Star Trek.
It does.
Break it down for me.
So imagine this. Instead of training an AI on thousands of recordings labeled car horn, right?
Yeah.
You teach it to understand the very concept of a car horn.
Okay.
The sharp blast, the way it cuts through traffic noise.
Yeah.
That's the holy grail of ZSAC. Getting AI to recognize sounds it's never encountered before.
So like Shazam, but a million times smarter.
Exactly.
No more awkward pauses while your phone tries to figure out if that's Led Zeppelin or a cat screeching in the alley.
Precisely. But traditional models hit a wall trying to achieve this.
Really?
Yeah, the paper highlights how these models are like picky eaters. They need massive data sets of specific sounds with very, very specific labels. And even then, they struggle to generalize. Remember that example of the AI that aced sound of a toothbrush?
Yes.
But completely choked on brushing teeth.
Yeah, that always blows my mind. It's like, come on, AI, even I can connect those dots.
Right.
So How does Reclap overcome this? What makes it so special?
So Reclap is doing something radically different.
Okay.
It's not just about what a sound is,
Yeah.
but how we understand it. Think of it like this.
Okay.
If a traditional model is like a dictionary,
Okay.
just listing words and definitions,
Okay.
then Reclap is like a poet with a thesaurus.
Okay. I'm intrigued. Tell me more.
So they used a large language model, or LLM,
Mm-hmm.
to supercharge the way sounds are described.
Okay.
Instead of a bland caption like a traction engine is idling,
Right.
Reclap generates something much richer, like a low rumble emanates from the heart of the iron beast, its diesel engine throbbing like a mechanical heartbeat.
Wow, that's quite the glow up for a traction engine.
I know, right?
It went from 0 to 60 in terms of sonic detail. They call that caption augmentation. Right.
They do.
But wait, there's more, isn't there?
Yeah.
It's not just about flowery descriptions. So we've decked out our AI with, like, noise-canceling headphones and a thesaurus.
Right.
What's next on this sonic makeover?
Well, that's where prompt augmentation comes in.
Okay.
So instead of using like generic prompts like identify this sound,
Right.
Reclap crafts really unique prompts for each sound.
Okay.
Almost like giving the AI a detective's magnifying glass.
Okay. I like it.
So for example, instead of just playing an organ sound,
Right.
they might prompt it with something like, in the hallowed halls of the cathedral, a symphony of pipes resonated with ancient hymns.
Oh, wow.
Yeah.
So it's like giving the AI, like, context clues, right?
Yes.
Exactly.
To help it understand not just the sound itself,
Yeah.
but also like the environment
Yes.
and the feeling it evokes.
Precisely.
Clever.
Yeah.
But I mean, does all this fancy language wizardry actually translate into like better results?
Well, that's the million-dollar question.
Right.
And the research suggests a resounding yes.
Okay.
Reclay outperformed previous models by significant margins on benchmark tests, sometimes by over 50%.
Wow.
Yeah,
That's huge.
it is.
Okay, I'm sold. Reclay sounds like a game changer.
It really is.
But let's talk real-world impact for a sec.
Okay.
How does this tech actually change things for, say, the average podcast enthusiast like myself?
Well, imagine a world where your podcast app doesn't just let you search by title or host,
Right.
but can actually, like, understand the content of episodes? Oh, wow.
Right. You could search for things like, find me a podcast with a soundbite about the Roaring '20s.
Okay.
Or find an episode where they discuss the ethics of AI with a sense of skepticism.
Now that you mention it, that would make my podcast binging sessions so much more efficient.
Right.
No more endless scrolling trying to find that one juicy soundbite I vaguely remember.
Exactly. And it goes beyond podcasts, too.
Really?
Yeah.
Like what?
Think about how this could revolutionize assistive technologies for the visually impaired.
Oh, wow.
Instead of just having a screen reader announce dog barking,
Right.
imagine if it could provide a richer description.
Okay.
Like, a small, playful dog is excitedly greeting its owner.
Wow, that would be amazing.
Yeah.
It's like giving someone the gift of sonic sight, allowing them to experience the world in a whole new dimension.
Precisely.
Yeah.
And that's just scratching the surface.
Wow.
Yes,
Yeah.
so there's more.
Reclap has the potential to transform everything from music discovery to security systems to how we interact with our smart homes.
So we're talking about a future where AI can not only hear us,
Yeah,
but truly understand us,
it's true.
picking up on subtle sonic cues that even we might miss.
Right.
It's both exhilarating and a little bit daunting, isn't it?
It is. And
Yeah.
that's what makes this area of research so captivating.
Yeah.
We're not just building smarter machines, we're essentially expanding the way AI perceives and interacts with the world around it.
It's like we're giving AI a crash course in sonic storytelling.
Yes, exactly.
But what are the chances that this tech could backfire in some way? Well, there are always risks with any new technology, but
Yeah.
the researchers behind Reclap are acutely aware of the potential pitfalls.
Like what should we be keeping an eye on as this technology continues to evolve? Like what should we be keeping an eye on as this technology continues to evolve?
Well, one thing is, like, you want to make sure that these AI models are trained on diverse data sets,
Okay.
representative data sets.
Right.
If we're not careful, we could end up with AI that's tone deaf, so to speak.
Right.
Misinterpreting sounds based on cultural biases or,
Yeah.
limited exposure to the full spectrum of
Yeah.
human sonic expression.
So just like with any AI, it all comes back to the data, making sure that, we're not accidentally teaching it to hear the world with a biased ear.
Kind of biased ear.
Right. Yeah.
Exactly.
Yeah.
We need to make sure that the data sets used to train these models reflect the richness and diversity of human sonic experience.
Right.
From different languages and accents to a wide range of emotional expressions.
It's fascinating to think that, we're now at a point where we need to teach AI not just what sounds are,
Right.
but also the nuances of how those sounds are perceived and interpreted in different contexts.
It's true.
Yeah.
It's a new frontier in AI research.
Yeah.
And one with incredible potential.
Totally.
Imagine a world where AI can not only transcribe speech,
Right.
but also understand the emotional subtext, the humor, the irony,
Right.
the full richness of human communication.
It's like we're giving AI the ability to appreciate the symphony of human experience, not just the individual notes, right?
It's true.
Yeah, that's a powerful thought.
It is, and it raises some, intriguing questions.
Like what?
What happens when AI can grasp the subtleties of a Beethoven symphony?
Wow.
Or the raw emotion in a blues song?
Yeah.
Could it eventually learn to create its own art forms, inspired by the sounds of humanity?
That sends shivers down my spine. It's both awe-inspiring and a little bit terrifying to think of AI, like, tapping into that level of,
Right.
creativity.
Yeah.
It feels like we're on the verge of something truly transformative.
Oh, you are?
Not just in terms of technology, but in how we understand ourselves and our place in the world.
It's true.
Yeah.
It's really, truly fascinating to think about.
Well, on that note, I think we'll leave our listeners to ponder those possibilities.
Yes.
If you thought AI was already changing the game, get ready for a whole new level of sonic disruption.
100%.
Thanks for joining us on this fascinating journey into the world of reclap and the future of sound understanding.
Absolutely.
Until next time, keep those ears open and those minds curious.
Have you ever told your phone to navigate to a new restaurant and it just completely butchers the name?
Happens to the best of us, right?
Totally.
Yeah.
But you know what's going on behind the scenes there. That's grapheme to phone conversion, or GDP for short. Basically, your phone trying to figure out how to say a written word out loud.
Which, sounds simple enough when you put it like that. But trust me, getting a computer to understand all the weird little quirks of pronunciation.
Yeah, all the little exceptions and things.
Exactly. It's no easy feat. Take the word read, for example. Spelled the same, whether it's past or present tense, but we pronounce it differently, right?
Oh, for sure.
These kind of little things, they keep researchers up at night.
And just when they think they've cracked the code, you throw a language like Persian into the mix, where even the written form can be a bit ambiguous, to say the least.
Definitely can be a challenge.
But hey, that's what makes this deep dive so interesting, right?
Absolutely.
We're looking at some cutting-edge research using AI to seriously up the GTP game, specifically for Persian.
And not just any AI.
Oh, no, we're talking about the big leagues here. They're using LLMs.
The same tech that powers ChatGPT.
Exactly.
Which is really exciting, actually, because it represents this really cool merging of natural language processing and speech synthesis.
Right.
And this research really digs deep into how LLMs, with their ability to actually understand context, and generate human-like text, can be used to overcome some of these big hurdles we've always had in GDP, especially for a language as intricate and nuanced as Persian.
Okay, so before we even get into the how they did this, let's talk about why GDP for Persian is such a challenge in the first place. The research uses this great example, talking about the words for flower and mud in Persian, and it really caught my eye.
Oh yeah, great example.
Because it highlights how tricky this can be.
It's a perfect illustration of what we call polyphone words.
Which are?
Words that are spelled the same but pronounced differently depending on the context, right? Like that read example we were just talking about.
Right, right.
Persian has a lot of these.
It does.
It does. And it's mainly because of the way that vowels are used, or rather, not used in written Persian.
Ah, okay, so like the written language is almost playing a prank on you. Like, good luck figuring this out.
Yeah, kinda.
So tell me more about these mysterious missing vowels.
Well, they're called diacritics, and they're these tiny little markings, and they indicate the short vowel sounds. But in everyday Persian writing, these diacritics are often just left out.
They are.
Yeah, they are. So you have to rely on context clues and your understanding of the language to figure out the correct pronunciation.
Wow.
Tricky for humans, let alone for a machine.
Yeah, no kidding. Okay, so that kind of explains the whole flower and mud thing a little bit. But then they bring up something called izafe, which sounds even more mind-boggling.
Yeah, izafe. It's one of those things that seems small, but it's so essential to understanding the meaning in Persian.
Really?
Oh, yeah. Think of izafe like almost an invisible piece of grammatical glue that connects words together.
Okay.
And it's often pronounced as a short E sound.
Yeah.
But it indicates all these things like possession or description or relationships between words. So it's small, but it carries a lot of weight.
Wow. So like one tiny sound can completely change what a sentence means?
Absolutely.
Okay, you're going to have to give me an example because my brain is not
Yeah, for sure.
wrapping around this.
Let's take 2 sentences. This is Zeba's flower,
Okay.
and this flower is beautiful.
Okay.
In written Persian, without those diacritics we were talking about, they might look very, very similar.
Wow.
Oh, yeah.
Wow.
But that izafe in Zeba's flower, it changes how it's pronounced and tells you who the flower belongs to.
Yeah.
Without it, you wouldn't know if we were talking about a specific flower or just flowers in general.
Oh, wow. Okay, yeah. That little E sound is doing a lot of heavy lifting there.
It is. It is.
No wonder traditional GDP systems have really struggled with Persian.
Exactly. Because it's not just about matching letters, 2 sounds one to one. You need to actually understand the grammar and the context. And that's where LLMs, with those powerful language processing abilities, come in.
Yeah. I mean, at first glance, it does seem like LLMs would be the perfect solution, right?
It would seem so, yeah.
Because they understand language in a way that previous systems just haven't. So, problem solved.
Well, not quite. I mean, LLMs definitely have incredible potential, but they're not a magic bullet,
Right.
especially when you're dealing with what we call under-resourced languages like Persian.
Under-resourced.
Yeah, it basically means that there just isn't as much data available for training them compared to a language like English, which has been studied and analyzed and used to train models for much longer.
So even the smartest AI still needs, like, good learning material.
Exactly.
It's like expecting someone to cook a gourmet meal, but only giving them, like, 3 ingredients.
Exactly. Yeah, you need the right ingredients to get those good results.
Exactly. And from what I understand, it seems like some of the previous research in this area, trying to tackle this problem, it sounds like it had some limitations.
It did. A lot of the previous studies really focused on what we call word-level G2P,
Word level.
meaning they were trying to get the pronunciation of just single words correct, in isolation,
Okay.
without really taking into account the surrounding sentence.
Got it, got it.
Plus, a lot of the prompting methods they were using, the ways they were actually interacting with the LLMs, were fairly basic. So they were basically just giving the LLM a word and saying, like, hey, give me the phonetic transcription of this. But they weren't really tapping into its full potential.
So it sounds like this new research had to kind of come at this from both angles.
Yeah.
Better data and smarter ways of using these LLMs.
Exactly.
And that's where things get really, really cool.
Yeah, and they really kind of upped their game in this research. Like, they really went above and beyond, especially when it came to the data.
Oh, really?
Yeah, they actually built this incredible resource called Kamaldict, which is essentially this massive, massive Persian GDP dictionary.
Okay, so it's like a dictionary, but for pronunciation.
Exactly. But it's not just any dictionary.
What do you mean?
This thing is huge. We're talking over 120,000 entries.
Wow.
It's like the ultimate cheat sheet for Persian pronunciation.
Okay, so they've got this ultimate cheat sheet now.
Mm-hmm.
But even with a dictionary that good, that can't solve the whole context problem, right? Like we were talking about before.
You're absolutely right. A dictionary alone can only get you so far. And the researchers, they knew this.
They did.
Oh, yeah. That's why they also created something called Sentence Bench, which is this totally new benchmark data set. And it's designed to test how well these GTP models actually handle those really tricky polyphones and ESAFE situations, but within the context of a full sentence, not just individual words.
Oh, okay, so that makes sense.
Yeah, it's like they built this obstacle course for AI, but specifically to challenge its pronunciation skills.
I love that. An obstacle course for AI. So they've got the LLM, they've got this massive dictionary, and they've built this obstacle course. So what, do they just like unleash the AI and see what happens?
Well, they could have, I guess.
Yeah?
But these researchers are smarter than that.
Okay.
They knew that LLMs, even as powerful as they are, they still need a little bit of guidance. Like, you need to kind of point them in the right direction sometimes.
Right.
So they started experimenting with different ways of prompting the LLM. It's kind of like giving it really specific instructions.
So it's all about how you ask the AI the question. like giving it the right clues to solve a puzzle almost.
Sure. Yeah, exactly. They started with a really straightforward approach, called it the naive approach, where they basically just gave the LLM a Persian sentence and said, okay, tell me how you would pronounce this, but use the International Phonetic Alphabet.
So like straight to the point, no messing around.
Exactly.
Okay. And how did that work out?
It wasn't terrible, but they knew that the LLM was capable of so much more. It was like they had a racehorse, but they were only letting it walk.
Okay.
So they decided to try something called in-context learning.
In-context learning.
Yeah, imagine showing someone a few flashcards before a test, right? Just to kind of like jog their memory.
Yeah.
It's kind of like that. They gave the LLM a little bit of extra information, some examples, some context to help it connect the dots.
Okay, so instead of just throwing it in the deep end, they're kind of deasing it into the pronunciation pool.
Exactly. Give it some floaties.
Okay. So did that do the trick?
It helped. They were getting better results, but they didn't stop there. They then tried this really, really interesting tactic, using what they call Finglish.
Finglish? Like writing English with like a Persian accent?
Kind of, sometimes people, they'll write Persian, but they'll use the English alphabet.
Yeah.
It's not exactly proper Persian, but it often includes more phonetic information just because English has more ways to represent those vowel sounds.
Right.
So they thought, well, what if we ask the LLM to kind of produce the Finglish version of the sentence?
Oh, okay. Thinking it might be easier for the AI to then pronounce it.
Exactly.
That is so clever.
And you know what? It actually worked.
It did.
It did. And the reason is that LLMs, they're trained on this massive amount of text data. And that includes those informal writing styles like Finglish.
Right.
So they can understand it, they can generate it. It was pretty cool.
That's so smart. Okay, so they're like thinking outside the box here. The LLM aces the Finglish test. So what do they throw at it next?
Well, they had this amazing new dictionary they had built, Camel Dict.
Right.
And they wanted to really put it to good use.
What force?
So first, they tried this thing, incorporating it in a rule-based way.
Rule-based.
Yeah, so imagine you've got like an autocorrect feature, right? But it's specifically trained on all those really subtle nuances of Persian pronunciation.
Okay.
So they basically used the dictionary to help the LLM catch and correct any minor pronunciation errors.
So they gave it a pronunciation coach. I love it.
Exactly. Did it help? It did, actually. Even those small corrections, they made a difference.
They did.
They did. But of course, they didn't stop there.
Oh, no, of course not.
They took things even further to a whole other level with this thing they called LLM-based dictionary correction, which gets a little meta.
LLM-based dictionary correction.
Oh.
Okay, now you've lost me.
Yeah.
I thought the whole point was for the AI to do the correcting.
Right. But instead of just blindly following some rules, they basically gave the LLM the freedom to use its own judgment.
Yeah.
So it would look at its initial output, compare it to what was in the dictionary, and then choose what it thought was the most likely pronunciation.
So it was like cross-referencing its work.
Exactly. Double checking.
With the dictionary. Okay. That's very meta. And it worked.
It did. Because by giving the LLM both the information and that freedom to kind of make its own judgments, it seemed like they were able to get even more accurate pronunciations. But remember how we were talking about how prompting is key?
Yeah, like giving it those right instructions.
They took prompting to a whole new level with something they called dictionary hints. Well, they found that the most successful strategy combined elements from the dictionary hints and LLM-based correction methods.
Oh, okay.
They called it Method 6-2, and it involved 2 key steps.
2 key steps. Okay, I'm a listener.
First, they would give the LLM a sentence and ask it to produce the phonetic transcription like we talked about before.
Right.
But then instead of leaving it at that, they'd ask the LLM to refine its own work based on hints from the dictionary, focusing specifically on single phone words.
Single phone words. So words with just one sound, like A or I. Why were those so important?
That's a great question. It turns out that providing the phonetic transcriptions for these single phone words was incredibly helpful for the LLM, especially when it came to those tricky Azafi situations. Remember how the Azafi is just this tiny sound that can change the whole meaning of a sentence?
Yeah, it's like the tiny but mighty ninja of Persian grammar.
Exactly. By giving the LLM these single phone hints, it was almost like they were highlighting the rhythm and flow of the sentence, making it easier for the LLM to understand where the Azafi should go.
So it's like they help the AI hear the music of the language, not just the individual sounds. But did all this work actually pay off? Did Method 6-2 actually make a difference?
It absolutely did. This method consistently achieved the lowest error rate on their benchmark dataset, meaning it made fewer pronunciation mistakes than any of the other methods they tried.
Wow, so not only do they create these amazing resources, but they also found a method that actually outperforms traditional G2P models. That's huge. But beyond just being accurate, were there any other advantages to this approach?
What's even more impressive is that method 6.2 was also much faster and more efficient than some of the other methods, which involved multiple steps or complex calculations.
Yeah.
Sometimes the most elegant solution is also the simplest.
It's like they found the holy grail of G2P, accurate, efficient, and elegant. But this is all well and good in research papers, so how does this actually impact people in the real world?
Well, think about all the ways we interact with technology using our voices. Virtual assistants, GPS navigation, accessibility tools for people with disabilities, the list goes on. All of these rely on accurate G2P to work properly.
So better G2P means a more seamless and natural experience with our devices. No more yelling at our GPS because it can't understand the name of that new restaurant.
Exactly. But it goes beyond mere convenience. Imagine more natural-sounding text-to-speech applications. Imagine a world where synthesized voices no longer have that robotic tone and can convey emotion and nuance, just like a human speaker.
It's like we're breaking down another barrier between humans and machines, and the fact that they tested this method with different LLMs, including open source models, is huge, right? This technology isn't just locked away in some tech giant's lab.
You got it. The potential for innovation in speech technology just exploded. By making their research and resources open and accessible, they're empowering developers and researchers around the world to create new and amazing tools for everyone.
This is so inspiring. It feels like we're on the verge of something truly transformative.
We are, and here's one more thought to leave you with. This research isn't just about improving how machines understand existing languages. It could also play a vital role in preserving languages that are in danger of disappearing. Imagine using this technology to create accurate pronunciation guides or even immersive language learning tools for endangered languages.
So instead of just preserving these languages in textbooks, we could be using AI to help bring them back to life. It's an incredible thought.
It is, and as we wrap up this deep dive, it's a powerful reminder of the potential for AI and language technology to not only help us understand each other better, but to celebrate and preserve the incredible diversity of human language. Ever get that feeling like, those online recommendations, they're so hit or miss. Sometimes they just nail it, but then other times it's like, come on, seriously.
Yeah, I know what you mean. It's a common pain point, actually. It kind of gets to the heart of some of the limitations we see with recommender systems as they are now.
And that is a perfect jumping off point for this deep dive. This paper, Beeformer, Bridging the Gap Between Semantic and Interaction Similarity in Recommender Systems, is really trying to tackle this problem head-on.
It really is. Most recommendation systems we see today, they kind of lean on either your past interactions, what you've clicked on before and all that, or they're using descriptions to find stuff that's, like, similar. But what's interesting is this paper, it really digs into how you can have one without the other.
Okay, I think I need an example. I'm not quite wrapping my head around that.
All right, so picture this. You buy a new phone. What happens? You get bombarded with all these recommendations for similar phones, right? Like constantly.
Yeah, makes sense.
Right. So that's the description-based approach in action. It's just finding stuff that, on paper, sounds alike. But think about it. What you really might need after buying a new phone. Probably a case, right?
Yeah, definitely.
And a case. It doesn't really have strong semantic similarity to the phone itself.
So it's not just about what sounds similar on paper. It's about, like, understanding what people actually do. Like, after they buy that new phone, what's next? And kind of predicting that connection, even when the descriptions are totally different.
Exactly. You got it. And that's where this whole Beeformer thing comes in. It's really trying to bridge that gap, by looking at both the semantic similarity, how alike things sound, and the interaction data, what people actually do, what they click on.
So instead of just looking at the book cover, it's like Beeformer is peeking inside your reading journal, too.
That's a great way to put it.
It knows you always go for a good fantasy novel after you finish, like a deep dive into some historical fiction.
Exactly. It's all about recognizing those patterns, right? The ones in your behavior that go beyond just basic keyword matching. And get this, the research. It actually found that this Beeformer system consistently outperformed existing systems, especially in those cold start situations.
So even if you're, like, brand new to a platform, Beeformer could still give you some surprisingly good recommendations. Man, no more wading through endless suggestions that are totally irrelevant just to, like, train the algorithm. That's amazing. But, okay, how does it actually work? What's going on under the hood?
So essentially, it utilizes this AI model. It's called a sentence transformer. Basically, what it does is it analyzes text, and then it creates this kind of summary, a fingerprint almost for every single item.
Okay, so it's reading all the descriptions, figuring out what each thing is all about on a deeper level, but then what? So it's got these fingerprints, but then it needs to actually do something with them, right? That's where your interaction data comes in.
Precisely. Beeformer takes those fingerprints, those summaries of each item, and then cross-references them with actual user behavior. It's like saying, okay, this group of people all love this mystery novel. What else do they interact with?
Even if those other things seem completely random at first glance.
Exactly. And that's where Beeformer can uncover those hidden gems, those unexpected connections that a traditional system might miss. It's not just about giving you more of the same, it's about expanding your horizons based on your actual behavior.
That's what I'm all about, discovering something new and awesome that I never would have found on my own. But let's get practical for a second. How does this translate into, say, my online shopping experience?
Well, imagine browsing for new headphones online. Instead of just showing you more headphones with similar specs, Beeformer might suggest a specific type of headphone stand that people with your listening habits tend to love. Or maybe even a noise-canceling app that pairs perfectly with those headphones based on your past purchases.
Okay, that's seriously cool. It's like it understands the context of what you're doing and what you might need next even before you do. But this almost sounds too good to be true. Were there any limitations in the research?
One interesting thing they discovered was that Beeformer could actually transfer knowledge between different domains. So, for example, a Beeformer model trained on data from a music streaming service could potentially make surprisingly accurate book recommendations.
Wait, hold on. Are you saying this one system could potentially power all kinds of recommendations across completely different platforms?
It's a tantalizing idea, isn't it? And it hints at the power of this approach. Now, this particular research focused on text descriptions, but imagine if Beeformer could analyze other types of data as well.
Like what? Give me some examples.
Think about images, videos, even audio. Imagine if Beeformer could understand not just what a movie is about, but also the visual style, the soundtrack, the pacing, and connect that with your viewing history.
Wow. We're talking like next level personalization here. Recommendations that are actually in sync with, everything about our tastes. It'd be like having this personal assistant who not only knows what you like, but can actually introduce you to new stuff you wouldn't find on your own.
Exactly. That's it. It's about enriching our experiences,
Yeah.
helping us find those hidden gems we didn't even know to look for.
This Beeformer thing is starting to sound like a real game changer. But okay, let's bring it back to the research for a sec. Did they actually test how well it works for brand new users, people who don't have any history on a platform?
They did. They actually ran tests in what they called a zero-shot scenario. Basically, they fed Beeformer data from users it had never, ever seen before. So simulating what happens when you're totally new to a service.
So the ultimate cold start challenge had to do.
Well, even without any prior knowledge of those users' tastes, Beeformer still held its own. It wasn't perfect, of course, but it really suggests that Beeformer isn't just memorizing patterns. It's actually learning something deeper about the connections between, items and actual preferences.
That's really impressive. Okay, so for someone like me just trying to navigate the digital world without drowning in a sea of irrelevant recommendations, what's the key takeaway? What does this all mean for the future?
I think the biggest takeaway here is that we're on the verge of a massive shift in how AI understands and responds to our needs. Beeformer, it's a glimpse into a future where recommendations, they're more than just this list of vaguely related items. They're actually curated suggestions that get your unique tastes, your unique behaviors.
No more algorithmic echo chambers, just a world of personalized discovery. It's a really exciting thought. I'm super curious to see how Beeformer and tech, it continues to evolve.
This has been awesome. Thanks for taking us on this deep dive. It's given me a whole new perspective on the power of AI. It's been my pleasure, really. It's always fascinating to kind of dig into this cutting-edge research and see how it has the potential to totally transform our online experiences.
It's really incredible, how we connect sounds to meaning without even thinking about it.
Yeah.
Like a baby recognizing their parent's voice way before they even understand language.
Right.
Or the way we just automatically associate the sounds of laughter with joy.
Absolutely.
Or a clap of thunder with a storm coming.
Yeah.
But what about AI?
Right.
Can we teach it to understand the world through sound in the same way.
Yeah.
That's what we're going to be diving into today with
Okay.
this research paper.
I'm looking forward to it.
AudioBERT, Audio Knowledge Augmented Language Model.
Interesting.
So it's a big question.
It is.
And this paper, I think, offers kind of a new way of approaching it.
Yeah, and to understand that challenge.
Yeah.
I think it's really important to remember that, like, most of the language models that we have today are trained basically just on text data.
Right. Which makes sense when you think about it for things like, translation or writing. But how do you capture something like a symphony orchestra?
Right.
Or the emotions in someone's voice?
Yeah.
Using just text. It seems almost impossible.
Exactly. It's like trying to describe color to someone who's been blind since birth.
Right, right.
Words can only go so far.
Totally.
And it's not just a theoretical problem.
Yeah.
Recent research has shown that AI can really struggle with what's called visual common sense.
Okay.
For example, like some language models have a hard time identifying the color of everyday objects,
Interesting.
even though to us it seems obvious.
Right.
So researchers are starting to wonder,
Yeah.
could the same be true for sound?
Okay.
Could AI be missing out on key information
Right.
because it doesn't hear the same way we do?
That's a really interesting question.
Yeah.
So how do you even test an AI's ability to, understand sound?
So they had to get creative.
Okay.
The researchers in this paper created a benchmark
Okay.
called Auditory Bench.
Got it.
And it's specifically designed to figure out how well AI understands sound and how it connects to language.
Okay, so I have to ask.
Yeah, go for it.
What kind of challenges are we talking about here?
Right.
Are they making AI listen to whale songs
Wow.
to identify different species or something?
They did use animal sounds in one part. So, they'd present the AI with the word meow
Yeah.
and then see if it could pick out a recording of a cat meowing
Okay.
as opposed to, a bark or a chirp.
That's pretty cool.
Yeah.
I wonder how I would do if they started throwing in more obscure animal sounds.
Yeah.
What does a pangolin sound like?
Who knows?
No idea.
It highlights how much of our auditory understanding is based on real-world experience.
It really is.
But the researchers didn't stop there.
Okay.
They also tested the AI on comparing sound pitches.
Okay.
So could it tell which sound would be higher, a synthesizer or a bass guitar?
Right, right.
Which is really difficult to describe with just text.
Yeah, that is a tough one.
Yeah.
When you think about it, it makes you really appreciate the power of human hearing.
Yeah.
And just how much information is packed into sound.
100%.
So how did the AI do on these challenges? Were they able to keep up with us humans?
Well, it's interesting.
Okay.
The results were kind of what you might expect.
Okay.
Standard language models, the ones that are mainly trained on text,
Yeah.
they didn't do so well on Auditory Bench.
So they're not ready to take over judging dog shows just yet?
Not just yet.
Okay.
They really had a hard time
Yeah.
making the connection between the description of the sound and the actual audio.
Okay.
It seems like experience is really important.
Yeah.
Even for AI.
Right.
But this is where things get really cool.
Okay.
The researchers, they didn't just want to point out the problem.
Yeah.
They wanted to find a solution.
Mm-hmm.
And that's where AudioBERT comes in.
Okay, so if standard AI is kind of like trying to understand music by just looking at the sheet music,
Yeah.
AudioBERT is like giving AI the ability to actually hear the instruments.
Yeah, that's a great way to put it.
Okay.
AudioBERT is all about
Yeah.
trying to bridge that gap between text and audio
Okay.
by giving the language model some knowledge about sound.
So that's a pretty big change.
It is.
How does that even work?
So AudioBERT has three main parts.
Okay.
First, it looks at the text
Mm-hmm.
and tries to find any words or phrases that would make more sense if you can hear them.
So if it came across the sentence like the cat let out a meow,
Right.
it would know that meow is a sound word.
Exactly.
Got it.
The next step
Yeah.
is where it gets really interesting. AudioBERT uses this other model called CLAP.
What is clap?
CLAP stands for Contrastive Language Audio Pre-Training.
Catchy. What does it do?
So CLAP is a big deal.
Okay.
It's trained on tons of text and audio data,
Okay.
and it learns to connect them.
Right.
So when AudioBERT sees a word like meow,
Mm-hmm.
Clapic can go and find related audio, like a recording of a cat meowing.
Oh, wow. So it's like having a huge sound library
Exactly.
that you can search by typing in words.
Exactly.
That's really cool. But how does AudioBert actually use that audio?
Okay, so this is the really clever part.
Okay.
AudioBert takes the audio,
Yeah.
in this case the meow sound,
Mm-hmm.
and it combines it with what the text says about meow.
Okay.
So it's like the text gives it a basic idea,
Right.
and the audio makes it way more real. Got it. Got it.
Just like it does for us.
It's like it can actually understand the word meow
Yeah.
so much better because it's hearing it,
Yeah.
not just reading the definition.
Exactly.
That is very cool. So we've talked a lot about meow, but
Right.
what about more complicated sounds or situations? How does it do with those? So AudioBird's good with simple sounds,
Yeah.
but what if it's something more complicated?
Right.
Like, how do we know if it can understand human emotion in someone's voice
Mm-hmm.
or interpret music?
It's a great question.
Yeah.
And this is where it gets really exciting.
Okay.
AudioBert is still really new,
Okay.
but it's a totally new way of thinking about AI
Mm-hmm.
and how it understands sound.
Yeah.
It's not just about matching sounds to words anymore.
Right.
It's about giving AI a deeper understanding of the auditory world. So it can actually understand what's going on,
Exactly.
not just identify the sounds.
Yeah, like imagine an AI that can listen to you talk
Okay.
and know when you're hesitating or when you're excited.
Right, we're being sarcastic.
Yes, exactly.
That's huge.
It is.
No more misunderstandings through text,
Right.
because the AI can actually hear the tone of your voice.
Exactly.
That's amazing.
And think about what that could mean for music.
Okay.
AI could analyze a piece of music
Mm-hmm.
and understand the emotions behind it.
Wow.
Maybe even compose music that makes people feel certain emotions.
That would be incredible.
It would be a whole new era
Yeah.
of AI-generated art and music.
Right, and it could help with so many other things,
Oh, yeah, definitely.
like speech therapy or even animal communication.
Exactly.
This is a huge step forward.
It really is. It all comes back to this idea
Yeah.
of giving AI the ability to hear,
Right.
just like we do.
So it's not just processing text anymore.
Right.
It's experiencing sound.
Yes,
That's amazing.
it is.
So we've gone from wondering if AI can tell a meow from a bark
Yeah,
to talking about AI that can understand what sound really means.
right.
It feels like this is a whole new chapter in AI.
I think that's a great way to put it.
It is a new chapter.
By figuring out how AI can understand sound,
Mm-hmm.
researchers are opening up so many possibilities.
It's exciting.
It really is.
We're getting closer to AI that can understand and interact with the world in a human way.
Exactly.
And that brings up so many questions
It does,
about how this will change things between humans and AI.
for sure.
If we teach AI to share like us, will it change how we talk to each other?
Mm-hmm.
How we create things?
Yeah.
Even how we understand ourselves?
It's definitely something to think about.
It is, and that's something for all of you to consider too.
It is.
As we wrap up this deep dive into AI and the world of sound,
A fascinating world.
it really is. I can't wait to see what we discover next.
Me too.
And to all our listeners out there,
Yes,
keep those ears open,
absolutely.
and we'll catch you on the next episode of The Deep Dive.
Ever get stuck solving those CAP-TCHA puzzles online? You know? Picking out crosswalks or deciphering that wobbly text just to prove you're not a robot. Well, new research suggests we might be on the verge of a world without CAP-TCHAs altogether. So today we're diving into the world of CAP-TCA busting AI, and we're looking at some cutting-edge research out of ETH Zurich.
Some really mind-blowing stuff.
Their paper's titled Breaking Recap-TCHA2.
Yeah, and it's really shaking things up in the world of online security.
It is. It is.
Yeah.
So they actually achieved a 100% success rate in solving those recap-TCHA challenges, the ones Google uses all over the place.
Yeah, the ones we see all the time.
Yeah.
It's incredible, 100%.
100%.
I mean, even the smartest AI systems are stuck at like 68% before this.
Right. What's their secret weapon?
So they use an AI model called YOLO, which stands for You Only Look Once.
Catchy.
And it's really, really good at real-time object detection.
Okay.
Basically, it can analyze images and spot objects very, very quickly and accurately, even better than humans can in some cases.
So it's like having superhuman vision, but for AI.
Exactly, exactly. But, and that's not even the whole story, the researchers also discovered something pretty fascinating about how Google's recap-TCHA system actually works.
Okay, now you have my attention.
Yeah, it turns out it's not just about solving those puzzles.
Really? So what else is going on behind the scenes?
So they found that Google relies really heavily on your browser history
Uh-huh.
and cookies to
Sure.
determine if you're actually human.
Interesting.
Yeah, the more extensive your browsing history, the fewer CAPTCHA challenges you'll encounter.
Wait, so all those late-night Wikipedia rabbit holes are actually doing me a favor?
It seems that way.
It's like Google knows I'm a real person because of my digital footprint.
Yeah, like it knows you're good for it.
Yeah.
It's a fascinating insight,
Yeah.
into how these systems work. But let's unpack the research a bit more. So the paper actually breaks down recap TCHF2 challenges into 3 main types.
Okay.
So first up, we have the classic image grids,
Yeah.
where you have to select all the images that contain a specific object, like bicycles or traffic lights.
Right, I've seen those a million times.
A million times,
Yeah,
right.
yeah.
And then there's the second type, which is a bit more complex.
Yeah.
So imagine a single image that's divided into a grid, and you have to select all the segments of that image that contain a specific object, like a motorcycle or something.
Okay.
This one requires like a different approach, even for AI.
So it's like those spot the difference puzzles.
Yeah.
On another level.
Exactly.
Yeah.
And then the third type
Okay.
is kind of similar to the first one with the image grids, but, and here's the catch, the images refresh dynamically every time you click on one.
Oh, wow.
Yeah.
So they're changing it up on you.
Yeah, exactly. That dynamic element adds like whole other layer of complexity
Right.
because the AI has to be so fast and adaptable
Right.
to keep up.
Yeah.
But yeah, let's talk about the AI versus human showdown.
Okay, so they put their YOLO-powered AI head-to-head with actual humans in a CAP-TCHA solving contest.
Yeah, they did.
They came out on top.
Well, the results were closer than you might think. The AI was slightly faster on average, but the difference wasn't actually statistically significant enough to say it was a clear winner.
Wow, so even with this super fast object detection, the AI was practically neck and neck with the human brain. That's both really impressive and also a little unnerving.
Yeah.
Does this mean that CAP-TCHAs are becoming obsolete?
I mean, it raises some big questions about the future of CAP-TCH technology, that's for sure, especially since Google has already moved on to recap TCH3.
Recap-TCHA, what is that?
So it's a more subtle approach. Instead of those like overt challenges that we've been talking about,
Yeah.
recap TCH3 kind of works behind the scenes. It analyzes your browsing behavior to assess risk.
So it's like an invisible CAP-TCHA.
Exactly, yeah.
Okay, so no more clicking on traffic lights or crosswalks. Sounds too good to be true.
It might seem that way, but there's always a trade-off.
Okay. With Recap TCHA3, we're essentially giving Google even more access to our online behavior, right?
I see what you mean.
They're using our data to determine if we're trustworthy enough to access a website or a service.
Right, it's like trading one form of verification for another, but with less transparency.
Exactly.
Yeah.
And that raises some really important questions, I think, about how those decisions are being made. What data are they using? How are they weighing different factors? We don't have a really clear picture of how these algorithms actually work.
Right, so if AI is already this good at cracking KTCHAs, and Google is moving towards these more invisible forms of security, what does the future hold for online security in general? What happens when the bots become even better at mimicking human behavior? That's the million-dollar question, right? Well, researchers and security experts are, they're exploring new approaches all the time. And one area that's showing a lot of promise is behavioral biometrics.
Behavioral biometrics. What is that?
So it's a really fascinating field, actually. Imagine, analyzing these unique patterns in how we interact with our devices, things like our typing speed, how we move our mouse, even the angle at which we hold our phones.
Wow, it's like a digital fingerprint. But instead of our fingerprints, it's our digital mannerisms.
Exactly. That's a great way to put it. The idea is that these really subtle, often subconscious behaviors are incredibly difficult for bots to replicate. So that's about building a digital profile, in a way, based on what makes us uniquely human.
That's brilliant. So instead of trying to outsmart the bots with ever more complex puzzles, we're kind of shifting the focus to what makes us, well, us.
Precisely. Exactly.
Yeah.
But it's not just about behavioral biometrics. We're also likely to see a lot more multi-factor authentication, where you need to provide multiple pieces of evidence to verify your identity.
Right, like those two-factor authentication systems.
Yeah.
Where you get a code texted to your phone or something.
Exactly.
Yeah.
But, we might see even more robust approaches in the future, like using physical security keys or biometric authentication methods like facial recognition or
Yeah.
iris scanning.
It seems like the future of online security is going to be a lot more
Well,
personal.
absolutely. Yeah, it's going to require a really delicate balancing act, though, between security and convenience, right? Because as we start to rely more on personal data to verify our identities, we need to make absolutely sure that data is protected
Okay.
and used responsibly.
It's a lot to consider, for sure. A lot of moving pieces. But it's super interesting, right? Like, it's clear that the world's online security is changing right in front of us. So for our listeners who are maybe trying to keep up with all this, what's the key takeaway for them?
You know, to me, the biggest takeaway is that the line between humans and machines is just getting blurrier and blurrier, especially when it comes to online interactions, you know? What used to be such a clear distinction is now so much more complicated.
Yeah. It's like we're entering this new era of technology where the boundaries between human ingenuity and artificial intelligence, they're constantly being redefined.
Totally. And it's exciting. It's not about being afraid of the rise of the machines or anything. It's about understanding how these advancements are changing the game and how we have to adapt our approaches to security to keep up.
Absolutely. So as we kind of wrap up our deep dive here, what's the one thing that you want our listeners to walk away thinking about?
That's a good question. I think, if KIP TCHAs are really on their way out, what comes next? Like, what will be the new standard for proving our humanity online? Will it be something we actively do? Or will it be something, happening completely behind the scenes? I think those are some really interesting questions worth pondering as we, continue to navigate this evolving digital landscape.
It's definitely given us all a lot to think about. A huge thanks to you for joining us on this fascinating journey into the world of CAP TCHAs, AI, and the future of online security.
Absolutely. My pleasure.
And to all our listeners out there, thanks for diving in with us. Don't forget to check out our show notes for links to the research paper we talked about and some other resources we mentioned. Until next time, keep exploring and keep those minds curious. We usually think about predicting the future with, like crystal balls and things like that,
Right.
hoping for a glimpse of what's in store.
Yeah.
But what if I told you that researchers are using AI to potentially predict the future of your health? And using something you probably already have, medical records.
Does sound pretty futuristic, yeah.
It kind of does sound like sci-fi, but it's real.
It is, yeah, using chest x-rays and the info in your medical records.
Wow.
Researchers have developed a framework, an AI framework that can predict how your future x-rays might look.
Wow, so it's all detailed in this research paper.
Yeah.
Towards predicting temporal changes in a patient's chest x-ray images based on electronic health records.
Yeah, and they've given this framework a pretty catchy name, EHRX-DIF.
Okay, so let's unpack this. Maybe we can start with the foundation here. Why are chest x-rays so important in understanding our health in the first place?
Well, chest x-rays are really common, and doctors use them to diagnose a lot of different conditions.
Right.
They give doctors a really clear picture of what's happening inside your chest, with your lungs and everything.
And because they are so common, then doctors are able to use them to track how things change over time.
Yeah, exactly.
Right, so like if you have a lung issue, they can see the progression of it.
Yeah, that's the idea. But a single x-ray is just a snapshot.
Okay.
It can't, on its own, predict how your health might change in the future.
Right, okay.
And that's where this EHRX-DIF comes in.
Okay, so it sounds like this EHRX-DIF is like this super-powered medical detective.
Yeah, you could say that.
That is combining the power of AI with a person's medical history.
Right.
Can you tell us a little bit more about how that actually works?
Well, imagine EHRX-DIF analyzing not just your past x-rays, but really diving deep into your electronic health records,
Okay.
prescriptions, lab results, everything to try to put together a really full picture of your health over time.
Okay.
And then it goes a step further and it actually tries to predict what your future x-rays might show.
Wow, so it's like it's able to see these subtle patterns and connections in our health data
Yeah.
that like a human might miss.
Yeah, you got it. And what's really remarkable is that it actually achieves a pretty high level of accuracy.
Really?
Yeah. But before we get into those results,
Okay.
maybe we can break down a little bit how it actually works.
Yeah, can you break it down for us a little bit?
Yeah. So at its core, EHRX-DIF, it relies on 3 kind of specialized tools called encoders.
Encoders,
yeah. And each encoder analyzes a different aspect of your medical data.
Okay.
So think of it like this. You have one encoder that's really focused on just the shape of your lungs.
Okay.
Another one that's looking at your x-rays with this highly trained eye,
Okay.
spotting subtle details.
Right.
And then you have another one that's really good at connecting the dots within your medical history,
Right.
considering things like new medications, procedures, that kind of thing.
So you have these 3 encoders, and they're all looking at different aspects.
Right.
But then how do they combine those findings?
Right. That's the key.
Yeah.
That's where this thing called the adapter module comes in.
The adapter module. Okay.
Yeah, you can think of it like a conductor in an orchestra. It brings all the pieces together.
Okay.
So it blends the insights from each of those encoders into one cohesive prediction of what your future X-ray might look like.
It's amazing how this AI can process like such complex information.
It is pretty amazing.
So how did it actually do though? When they tested it, did it actually work?
Yeah. So let's get into those results
Okay.
and talk about how EHRX diff fared when it was put to the test.
Okay, so they built this AI framework.
Right.
Sounds incredible, but like,
Yeah.
did it actually work in real world scenarios?
Yeah, I mean, the real test is in the results, right?
Right.
Researchers really wanted to see if EHRX diff could not only generate these like realistic looking X-rays,
Okay.
but also predict medically accurate information too.
So how do you even test that? It's not like you can be like, hey, what's your lungs going to look like next year?
Right, exactly.
Right.
So they conducted a bunch of really rigorous tests.
Okay.
And one of the important ones was to see if EHRX diff could predict specific conditions
Okay.
based on the past X-rays and the medical records.
So they just fed it like a bunch of data and then said, okay,
Yeah.
based on this, what do we think this person's X-ray is going to look like?
Exactly.
Right.
And what they found was that EHRX diff, it actually achieved around 80% accuracy
Yeah.
in predicting these changes in a patient's condition.
That's incredible.
Yeah, like the development or progression of a lung issue.
So like 80% accuracy.
Yeah.
That's like me knowing there's a really good chance I'm going to catch a cold before you even feel a sniffle.
Yeah. Yeah. That's a good way to put it. Not quite a crystal ball for every sniffle, but the accuracy is remarkably high, especially when you consider this is still early stage research, you know?
Okay, so what else? What other tests did they do to like really gauge the reliability of this?
Yeah, so they also wanted to make sure that EHRX diff wasn't getting tripped up by just basic demographic information.
Correct.
They tested it to see if it could accurately keep track of things like age and gender over time.
Wait, really?
Yeah.
I just thought like AI's good at that kind of stuff.
Well, you would think so, right?
Right.
But sometimes these models can actually develop biases.
Oh.
You know, like let's say, for example, an AI model was trained on a bunch of data that showed that most people with a certain lung condition are over 60. It might incorrectly assume that that condition is just like inherently linked to age.
Okay, so you have to make sure it's not like making these assumptions based on.
Exactly.
Yeah, okay, so, and how did it do?
So it turns out it did surprisingly well with gender. Almost perfect accuracy.
Wow.
But age proved to be a little bit trickier.
Really?
Yeah.
Huh.
It wasn't as accurate as it was with gender.
Interesting.
Yeah.
So even super smart AI has its limitations.
It does. Yeah.
Okay, so we've talked about the medical accuracy. We've talked about like these demographics.
Right.
But what about the X-rays themselves? Like,
Yeah.
did it actually generate images that look like real X-rays?
Yeah.
Or was it just like a jumbled mess?
No, that's where things get really interesting, actually.
Mhm.
So to assess how realistic those generated images were, they use this thing called an FID score.
An FID score.
Or an FID score, yeah. And basically you can think about it as like a way to measure how similar the AI-generated X-rays are to real ones.
Okay, got it.
And the lower the score, the more realistic the images.
Okay,
Makes sense.
makes sense.
Okay, so EHRX diff actually scored really well on this FID,
Okay.
especially when you compare it to other AI models that have been designed to generate X-rays.
Oh, so it's up there.
It's up there.
Okay.
The predicted images, they were detailed, they were sharp, and they looked incredibly convincing.
Wow, that's really incredible.
Yeah.
So it sounds like it passed all of its tests with flying colors.
I'd say so.
So what does that mean for,
Yeah.
the average person out there?
Right.
Like, should I expect to go to the doctor's office and see my predicted future X-ray hanging up on the white box?
Well, not so fast.
Oh, okay.
It's really important to remember this is still really early stage research.
Okay.
It needs to be tested on these larger beta sets.
Right.
There are a lot of considerations with any new technology, really.
Right, yeah, of course.
But there are some really, really exciting potential benefits.
Like what?
Well, one really exciting possibility is just in early detection.
Okay.
Imagine if doctors could spot these subtle changes in your lungs.
Okay.
That might indicate like the very early stages of a disease.
Okay, yeah, that would be
Yeah.
a game changer for sure.
Huge, right.
Yeah. Yeah, what else could it do?
Well, EHRX-Diff, it could also help to personalize treatment plans.
Yeah.
It could potentially simulate how different treatments might affect your lungs over time,
Oh, wow.
which would allow doctors to basically run these virtual trials to see what would be most effective for a specific person.
So they could be like, okay, let's try this treatment
Yeah,
and see what the AI says.
exactly.
Wow, that's incredible.
Yeah, it's really amazing stuff.
So was there any other like really interesting details that came out of this research?
Yeah, there was a really intriguing aspect of the research that really caught my attention.
Okay. Okay, so what was this intriguing aspect of the research? What caught your attention?
So they did this really interesting thing where they actually gave EHRX diff cases with no changes
Great.
in the patient's medical records.
Yeah.
They basically wanted to see what the AI would predict when there was nothing to report, you know?
Well, that's interesting. Would it just like try to invent some drama where there was none?
Right, and that's what's so cool about the results.
Yeah.
Because you'd think, the AI might overthink it or predict these changes where none existed.
Right.
But that's not what happened.
Okay.
EHRX diff was surprisingly good at recognizing those stable situations and predicting that the person's lungs would likely look very similar to their previous X-ray.
So it's capable of like recognizing stability and normalcy,
Exactly.
not just these like dramatic changes.
Right, exactly. And that's like super crucial for real-world applications, right?
Right.
Like, imagine if this technology becomes commonplace.
Okay.
And every time you went to get an X-ray, it also generated this, like, future prediction.
Right.
It wouldn't be super helpful if it was constantly predicting these, like, dramatic shifts
Right.
when your health was fine.
Yeah, you'd just be freaking out all the time.
Exactly, right. It would lead to all this unnecessary anxiety and testing, and
Right.
who needs that?
Right. So it's good to know that it's not like always predicting the worst case scenario.
Exactly.
Got it.
It highlights a certain level of like sophistication in the AI, I think.
Yeah.
It's not just about, just raising alarms. It's about like providing this balanced and accurate view
Yeah.
of a patient's, health trajectory over time.
This is mind-blowing, this whole thing. Like
I know, right?
it's like we've gone from gazing into crystal balls to AI that can like learn from our own medical journeys
Yeah,
and like potentially predict how our bodies might change in the future.
it's pretty wild.
It is pretty wild. It's both exhilarating and a little unnerving
Yeah, I agree.
at the same time, but
Red
it's
flag.
really, it makes you think,
It does. It really does.
Well, this has been an amazing deep dive into the world of AI and medical predictions.
Yeah, this was fun.
Thank you so much for joining us today. This has been great.
My pleasure. Anytime.
We'll catch you in the next episode.